Hello and good morning. Thank you for joining us today. I'm Nisha Sharma. I'm a managing director in Accenture. I've been at Accenture for just over 20 years and worked on all sorts of different technology implementation projects for clients across several different industries. I'm currently part of our Accenture Google Cloud Business Group, which we formally launched last year at Next. And I oversee all of our offerings and offering development for the partnership. And I'm based out of Miami, Florida.
Hi, so I'm Deb Santiago, and I'm based in Chicago. I am the co-lead of our responsible AI practice at Accenture, as well as a managing director in the legal department. So the way that it's going to work today is Nisha's going to go and walk through our tech vision document, and I'm going to respond, provide some thoughts with respect to what we're anticipating for the next 5 years and what can we learn from the past 5 years that can help us navigate and manage our entry into these new worlds.
There we go. All right, so every year, Accenture publishes a technology vision. This is our view of the top trends that we are seeing impacting our businesses today. We talk about technology trends as well as business trends and how the use of technology is impacting what our clients and what businesses are doing. We've been publishing the tech vision every year for the past 19 years, and we just recently published this year's 2019 tech vision in February. So, we thought we'd anchor this conversation around the responsible use of technology and the considerations of ethics around the future trends and what we see and where we're going, because this gives us an opportunity to consider these as we deploy our technology solutions. So I'd like to start by asking you two questions. Just think about these questions. First question is technology good or bad? Right? Think about all the different technology that you've come across, all the technology that you hear about. Is it good or is it bad? And the second question I would ask you is, what is your role? What is our role? What is our company's roles in influencing and determining whether technology is good or bad? So let's take a look at some examples to kind of set the context for our discussion here today. Technology can be very scary to people. There's a lot of negative news around technology and advancements in technology, right? Who should be trusted with this technology? Who shouldn't be trusted with this technology? Is it ethical? Is it not ethical, right? It can be quite controversial, even though we think there's some really advanced implementations and advancements that we're seeing in technology. We're still questioning the ethics and the responsible use of that technology. So there's some examples here just to kind of, show what we're actually seeing in the news, right? So over 3 billion identities were stolen online last year, right? We're questioning the geopolitical forces and the influences that we're seeing in today's world, right? Which countries do we trust with our technologies? Which countries are we willing to share our technologies with, right? Lots of questions around who we trust again and who we don't. Fake news is in the news every single day, right? There's a survey that says that the majority of people around the world don't think that they have a single source of truth for news these days, right? I just came back from a vacation in India, and they're getting ready for their elections, and there's a lot of concern around fake news being spread and really influencing and affecting the elections, right? Even after what we saw in our own elections here in the US. We're seeing questions around the use of technologies like facial recognition technologies. Again, we're constantly scanning everybody all the time, and we're identifying who these people are and who they aren't. Who do we trust with this? Who do we trust to see and learn from this information? The bottom left there is about a researcher in China that was using gene editing tools like CRISPR to modify human embryos, right? It sounds really advanced, but is that ethical, right? There's a lot of questions around this. We hear stories all the time about bugs or software gone wrong or something that we've discovered in our applications, like the recent FaceTime issue, right? Where you'd make a call through FaceTime, but the camera turned on before the the receiver actually had an opportunity to turn it on, right? We've got apps that are constantly requesting access to our photos, to our contacts, to our call logs and text messages, right? So we're just constantly asking the questions of what's happening with my privacy and my data. We're talking about inequality and inclusion, many, many questions. And then we're seeing this tech clash, right, against all the technology companies, whether they're in the Silicon Valley or whether they're in China. But they're constantly being asked, what are you doing with my information? What are you doing with this data? How are you using it? What are we really doing? But there are also some really amazing things that are happening, a lot of positive news around technology, right? So there's an example here of work we're doing on a program called ID 2020, which is about us helping refugees all around the world establish their digital identities so that they can get access to services that they might not normally have had access to because they can't demonstrate or prove who they are. We're seeing advances in the agriculture industry where we're using technologies like drones or IoT sensors and such to improve the quality of the food that we're producing and to help reduce food waste and so on. Advances in healthcare and medical services. This is an example, one of many, many examples, but using IoT devices and technologies to provide seniors and disabled people with new ways of getting exercise, right? Some fascinating advances in robotics, right? We're teaching robots how to do backflips and to dance better, right? So we're not going to be doing the robot anymore. They're dancing like us, right? Pretty cool stuff. And then the other example there with rockets. So traditionally, we've launched rockets up into the air, but they're kind of like these one-time uses of these rocket technologies. But companies like SpaceX, for example, are figuring out how to launch those rockets safely back down to Earth so we can reuse them. And so some really fascinating and really positive uses of technology out there as well. How many of you had heard about the 10-year challenge that was recently all around social media? It was where we were basically taking a picture of us 10 years ago and comparing it to a picture of us now, right, to show how much we've changed. Well, Bill Gates posted the world's 10-year challenge, and this was showing how, how social factors and social things have changed over the past 10 years. Life expectancy, extreme poverty, child mortality, youth illiteracy. We've seen really, really positive improvements over the past 10 years, and technology has definitely had a role in all of that. So technology can be good or bad, and that's based on how it's used. And it's really up to us to determine whether it's good or bad.
And the thing is change is constant. This isn't as though we didn't have technology changes in the past, but there's something very different right now about the pace, the scale, and the velocity of change that we're experiencing right now. Many of you have seen that S-curve slide around the technology adoption of in the US over the last 100 years. One of the often cited examples in that slide is that it took about 45 years or so for the telephone to achieve mainstream adoption, whereas smartphones only took about 10 years. And before, societies had time to kind of absorb the impact of technological advances. But we don't have that luxury right now. Because we are living in this time of rapid technology adoption, regulators are playing catch up, but they've also indicated that in the next 5 years, that they will be catching up with us all. And I think that what we're seeing is in this gap that the society at large is responding. We've got enormous public scrutiny and real-time feedback, and in some respects, forced transparency of the activities that companies are doing today. And as new tech like AI becomes mainstream, it's important to consider that the ethical implications right at the beginning is a central aspect of how we develop and deploy new technologies. As recent events have shown, it's really hard to get right. And the thing is, technology alone cannot deliver on the full promise of new technologies like AI. An important conversation is going on right now with respect to external advisory councils, et cetera. And it's facilitated by the community at large. And I would say that it's helping the tech world understand how the public views the way that companies should be interacting with us, engaging with us, and what they expect companies to represent, what communities they're expected to represent. But in the end, everything should not hang on one company, one person, one team, one regulation, one government. Rather, companies should be creating resilient and sustainable governance strategies that can help them act in an agile way to deploy technology responsibly.
So let's take a look at the technology vision, this year's technology vision. What it's all about is about this post-digital era, and we are now entering this post-digital era. In 2018, companies spent $1.1 trillion on their digital transformation projects. 94% of organizations say they're doing digital transformation work today. I don't know if I believe that, but that's what they said that they're doing. 58% of those organizations say that they're comfortable with where their digital transformation programs are going. So everyone says they're doing digital, right? And we need to figure out how to differentiate. We need to figure out what's next. And in this post-digital world, we're not saying that digital is done, not by any means. In fact, it's just table stakes now. It's required to be there. It's just the cost of doing business. And you know, I like that and at some point we're going to say that we're going to stop using the word digital even, right? I like how our CTO has said that, you know, we don't say we're in a post-electricity world anymore or post-internet world anymore. They're just there. Right? And so very soon we're going to see that digital is just like that as well. So now we've got a new set of characteristics that are defining what it means to be successful in this post-digital era. So we're going to just touch briefly on what some of these characteristics are, and the first one is individualization. Now, individualization is not personalization. We're talking about hyper-personalization, right? It's not just about knowing what your preferences are and what you like and those kinds of things, but it's about really understanding what you want and what you need. Instant on-demand is about being able to respond and deliver services to a customer exactly when they want it, right? They want it now, and we have to be able to deliver that. And then momentary markets are these pop-up-like services where we are able to respond to a customer's needs at exactly that particular moment in time, right? And these are, again, these markets that form very quickly. They provide an opportunity right then and there, but then they go away very quickly as well. And if you can't serve a customer's needs exactly when they want them, then you've lost that opportunity to engage with them. So now you can imagine all the information that's being captured in order to provide these types of services, right? And customers expect trust and responsibility, right? They expect that all the data that they're putting out there, you're using it responsibly, and that they're able to trust that, you know, that you're doing that. So I'd like to do a little experiment with all of you. So take out your phone. You know, you all have phones. Just take out your phone, right? Everybody got their phones? You got your phone? Now unlock your phone, okay? It's unlocked, right? Everyone's phone's unlocked. Now hand it over to the person next to you. Go ahead, hand it over and do something on the phone, right? Where's your camera here?
I don't know where your camera is.
Okay,
actually. I'm going to send an email.
Let's take a picture. Here. I'm going to take a picture. Where's your selfie mode? All right, now give the phone back. Now all of you laughed, all of you paused to think about, oh my God, I'm giving over this phone to the person whom I may or may not know. Think about all the things that are on.
And we're friends.
Yeah, and we're friends, right? I know Deb, but do I really trust her, or do I really want her to see all the messages that I'm exchanging with my sisters on WhatsApp, or all the photos that I've taken and that are stored on my phone, right? There's access to my banking applications. There's access to my emails. There's just so much information that I know is on this phone. And you know, we're all pausing and hesitating to exchange those phones. But we do this every day with data that is online and services that we use, right? We just publish things, we have companies that have access to these things, and we don't even think about it, right? We just trust that they are using this information responsibly, right? It's quite fascinating.
Yeah, so and part of my responsible AI work, I had a client reach out to me and say, have you ever done anything with like robots as an employee? And I was like, where is this question coming from? And they explained that they had taken a robot and introduced the robot to the workplace. And so the robot, it had eyes and was roaming the work floor. And they thought it was going to be enjoyable, but actually it completely backfired. People got very angry, and they said, one of the things that they said was, this thing is recording me, and it's invading my privacy. And as we were kind of brainstorming about this, we were just pointing out, I'm sure you guys have CCTVs all over the place recording your employees' activities all the time, and it just was that reducing it to a physical form that makes it come to life, where people really understand what is actually happening. So over here you'll see, these are the principles that we use internally in terms of our use of artificial intelligence at Accenture, whether it's from an HR perspective, a CIO perspective. These are the principles that we've been using. They are based on the common principles of FATE, so it's fairness, accountability, transparency, and explainability. So I'm not going to go into it. You can see here it stands for trustworthy, reliable, understandable, secure, and teachable. The one thing that I wanted to highlight is the item around understandable. And we were very intentional about taking it a step further from transparency. Why is that? Well, privacy policies are very transparent. Pages and pages of transparency. Nobody ever reads them, and people don't really understand. You don't say, that these privacy policies can establish trust with the end user. So we really wanted to think about, how do we stop putting the burden on the user to decipher what's going on? How do we take responsibility for our actions and make the things that we're creating understandable to the user? Because when we prioritize understandability, we're able to allow the user to understand the import of the actions and to enable trust quickly. And that this will be a very important point as we talk about momentary markets later on in this discussion.
Okay, so we talked about these characteristics of the post-digital business. Now let's take a look at the 5 trends that we've established as part of our technology vision for the post-digital era. And then we're going to discuss how we can apply those principles of responsible use and ethics that Deb just talked about. So the first trend is what we call the dark power. And this is about the technologies that we are now seeing companies use in this post-digital era. The D stands for distributed ledgers, right? And this is technologies like blockchain and cryptocurrency that we're using to, to have these more secure and protected and trusted transactions. So we're seeing examples of companies using technologies like blockchain in their supply chains to make sure that they're establishing that trusted, set of supply chain activities. We're seeing car makers use these technologies as a way to protect cars from getting hacked. We're seeing delivery service companies like DHL, for example, who are looking at blockchain technologies to make sure that you are receiving, for example, medication or drugs that you had ordered, and they're not counterfeit, and that they're really the ones that you had asked for. The A is for artificial intelligence, right? 67% of businesses say that artificial intelligence is being piloted or adopted at their organizations today. And 41% of executives ranked artificial intelligence as the one technology that they expected to have the most impact in their organizations over the next 3 years. So, and you'll see all sorts of great examples of artificial intelligence, hopefully here at the conference as well, as you walk around and see what other companies are doing. The R stands for extended reality. This is augmented reality, virtual reality, mixed realities, assisted reality, so on and so on. These are all about new experiences, right? We're looking at new experiences in terms of new ways of training, right? We can use virtual reality to simulate training environments or simulate actual environments so that workers can have a safe place to try and to learn and to test out new capabilities. New ways of shopping, right? New ways of interacting with products or gaining information in a store environment perhaps or things like that. And new ways of just exploring places, right? We can virtually visit a national park or a museum or any other such facility like that. The Q is for quantum computing, right? Quantum computing has brought about so many new advances and are really allowing businesses to explore new ways of solving very difficult problems or perhaps problems that they weren't able to solve before, right? We're working with a company called 1QBit, and we had collaborated to identify over 150 different use cases for quantum computing to help us solve, for example, drug discovery. Right? We can use quantum to quickly discover new types of drugs, or fraud detection, or route optimization, or so on. There's many, many examples of how quantum can help. Now, individually, each of these technologies provides an opportunity to differentiate, right? And we've already seen that 89% of businesses say that they're already experimenting with one or more of these dark technologies. But then imagine that together, right, these are going to open some really new pathways and some unimagined pathways into the future. Now, this shift to dark technologies is built on the digital foundation that companies have invested in and been investing in over the past several years, right? And have you heard of the term SMAC before, right? And SMAC is what is traditionally, called the digital technologies. That's social, that's mobile, that's analytics, and cloud, right? And these are considered to be the foundation of our digital solutions. And we're building upon those now, right, as we move to the dark technology. So as an example, augmented reality and virtual reality solutions run on mobile devices, right? The big data and the analytics capabilities that we had been setting up over the past several years, well, now we're extending those to artificial intelligence and machine learning. Those quantum computing services that are now being available, they're being made available through the cloud, right? So we're building on top of what we had already been establishing. And this now provides a foundation for companies to start to explore these dark technologies, which are really still in the early stages. So not only does it give us a head start, but it allows us to create new value from these previous investments and to extend our digital business into the future.
So we see enormous promise that extended reality can have. So for example, training, as you mentioned, can really increase the ability for people to empathize with the plight of others. A really great example, and I encourage you to go look for this on YouTube, is the NGO People for the Ethical Treatment of Animals decided to change their communication campaign. Actually, Accenture helped them with this. But they used the extended realities technologies to help people to engage with a rabbit eye to eye. It's called the eye to eye experiment. And it really had a profound impact on the public in terms of understanding and helping animal rights come to life. But when I think about, also the promise, but what are the things that we're thinking about whenever there's a huge institutional shift going from SMAC to dark, what are the things that we need to protect against? And what are the things that we need to maintain? So what shifts are we seeing? We're seeing a shift that's going from watching a video on your phone to having these very intense immersive experiences. And when you have these intense immersive experiences, it becomes very easy to come to a truth for me conclusion that can seem at times unshakable and permanent. And what we're shifting from is not just data being collected, but also data that can be possibly used for manipulation. There's a senator in Virginia who just today introduced a bill would like to propose banning the use of dark patterns for online platforms to prevent kind of the use of manipulated activities where people volunteer information about themselves without realizing how that information is going to be used. So we're shifting from data collection to possible data collection for manipulated experiences. And we think about the regulatory scrutiny that is coming, the combination of extended realities and, for example, deepfake technologies. And will the public start asking for guardrails, not just on fake news? This morning I counted, there are about 13 countries right now that are either proposing or have on their books legislation regarding fake news. But at some point, will the public also start asking for guardrails around not only just online safety for children, but around the creation of fake memories?
Okay, our second trend is called Get to Know Me. And this is all about the consumer. How do you reach the individual consumer? How do you provide the right services to those consumers, right? It's all about how we engage and interact. And you can think about all the SMAC technologies that we said we've been deploying, right? Social, the mobile, and so on. And we've collected so much information about each of us and all the users who are using these technologies. So you may have seen some of those charts that talk about what happens on the internet in a minute, in 60 seconds. Well, 3.7 million Google searches are done every minute, right? 4.3 million YouTube videos are viewed every single minute. 2.4 million snaps, right? 38 million WhatsApp messages exchanged every minute. And 187 million emails are sent every minute, right? So you can imagine now all of these interactions, all of these activities, they all say something about us. They all provide information about us. And companies are able to use that type of data to provide new types of services to individuals, right? So as an example, I'll share is a company called SlicePay. They're a financial services company in India, and they serve unbanked customers, right? So these are customers who don't traditionally use banking services or anything like that. But what they did was that they were able to use the pictures that people were posting online or the messages that they were sending or their other social interactions and create a financial profile of these individuals. And now they can provide services or offer services to these individuals using this profile that they were able to build based on that information. So, keep in mind that customers are making this information available to us, to our businesses, and they're relying on us and the businesses to use that information responsibly.
So again, when I think about the promise of individualization, it is the promise of instilling a sense that you are not only known and recognized, but also understood. And so we delight whenever a recommendation comes and it's correct. We delight whenever it's thoughtful or insightful. But when data is being scraped or being used in ways that the user didn't originally intend, as a society, we should pause. Are we creating systems that are learning to penalize people based on activities and data that they're providing that they never intended it to be used in this way? Are we making inferences on users that are just not reasonable? Again, we're seeing increasing scrutiny in this space. So the state of New York, the Department of Financial Services, in January just introduced a set of guidelines to insurance companies based in New York, saying that if you're going to use non-traditional data sources like social media posts, here are the guiding principles that should apply. But importantly, you need to be able to show, the burden is on insurance companies to be able to show that you are not using this data in a discriminatory way. So against protected classes of individuals, race, gender, et cetera. And just, by the way, just removing race and gender doesn't eliminate that problem. There are indirect ways of discrimination using proxy variables like zip codes that are going to get caught up into that. So how companies should anticipate and think through using those non-traditional sources of data. The city of Los Angeles recently filed a lawsuit against the Weather Channel alleging that, claiming that the Weather Channel had collected user location data on users who did not know that it was going to be sold to advertisers. And the state of Utah recently enacted a law that requires police to have search warrants before they can use and collect any kind of electronic personal data like social media posts. People are worried about everyday behaviors being penalized and criminalized. And they are especially concerned when the data sets by which these inferences or conclusions or recommendations are being made are either false, they're faulty, or simply incorrect. And I'm not even going to go into the whole bias discussion. We could spend like a whole hour just talking about how some of these systems are built with bias already embedded in them.
Our third trend is called human plus worker. This is about the workforce. Our research shows that more than 90% of jobs that we have today will change as a result of artificial intelligence, robotics, and other technologies. Jobs are changing fast. Each individual worker is empowered by not only their skills and their knowledge, but also by the new capabilities that technologies are providing. There's some examples here. In the oil and gas, we have an oil and gas company whose workers are now able to troubleshoot an issue a mile underground using game-like visualization tools. We have workers that are being trained as drone delivery pilots. These are jobs that didn't exist before. And we have factories where humans are working side by side with robots, and we're using artificial intelligence tools to help determine which jobs the humans should be doing and which jobs the robots should be doing, right? So the workforce is evolving, and companies do need to keep up to support these human plus workers. And there are three areas of focus that we have been exploring and working on improving. And one of those is around hiring, right? So the speed and the constantly changing nature of these human plus careers are making it harder for businesses to acquire this talent within their workforce. So they're moving away, and companies are being forced to move away from the more traditional reactive skills-based hiring, right? You don't just put out an ad for, I need someone who has 6+ years in, accounting skills or something like that, right? So, we've got companies, for Unilever as an example, who are now using games to screen candidates, right? And they're using these games to assess your memory. They're using these games to understand your acceptance of risk. They're understanding whether you take more contextual cues or emotional cues, right? And so it's a very different way of screening candidates. And then they're using, again, artificial intelligence tools to match these candidates with open roles, right? So just new ways of hiring. There's also training, right? So, we can't hire people necessarily to do the work that we require them to do now. People just don't have those skills. And, what we've seen is that 43% of businesses and IT executives say that more than 60% of their workforce will move into new roles over the next 3 years, and that's going to require substantial reskilling, right? We need to invest in reskilling and offering on-demand training opportunities for these employees. And the third area is around knowledge management, right? We have more information available to us than ever before, but it's also harder for us to access and to find this information. And we're, exploring new ways to make that possible, right? We're using technologies like natural language processing to be able to capture and assess, information and insights. We're looking at indexing of unstructured documents like incident reports, for example, as a way to collect knowledge and insights. We're incorporating knowledge graphs to be able to find information across a wide variety of different types of data sources. Right? So just new ways, again, on hiring, on training, and knowledge management.
So a news story was leaked rather recently about a certain Seattle company that had an AI tool that was screening CVs. And if you were a woman, you were immediately downgraded. And there was enormous backlash about what happened, et cetera. But when we looked at it, we actually said, hey, actually they had a really strong governance structure. They looked at this for 2 years. They recognized that there was going to be bias in the system and the bias in their existing hiring practices today. They tried to mitigate against it and tried to figure out ways in order to fix and adjust for that bias. And at the end of the 2 years, they couldn't fix it, and they decided to dismantle that program. And that story to me just told me about how important it is to really establish those governance strategies at the beginning as you start experimenting with artificial intelligence. At Accenture, we spent a lot of time looking at some of the tools that we use internally, but we also put a high level of importance on retraining and reskilling our workforce. Last year, we spent $900 million on retraining our people. And we use the money that we save from automation and artificial intelligence to upskill people. And for us, that really is important because we think it's important to democratize AI learning, and from an ethical point of view, making it accessible to those who may have there might be a high barrier to entry for some of these skills.
Our trend number 4 is called Secure Us to Secure Me. Right? Security is no longer about just protecting us as individuals. It's not about one person. It's about protecting all of us. And what we need to, what we've seen is that a lot of companies still think that security is an individual effort, and if they can just secure their own information and their own data, that they should be safe. But that's not the case at all, because what we're seeing is that businesses are rapidly entering these ecosystems, right? They're working with technology partners and industry partners to create new services and new products and new experiences for their customers. And attackers are really seeing these ecosystems as this ever-widening attack surface from which they can, try to do bad things. Only 29% of executives in our survey actually know that their technology partners are taking security and being just as diligent as they are in implementing security processes and solutions. So, while we continue to have the traditional risks that we always have, one of them has always been around the misuse of data. And we've always thought of it as a misuse of our own data and how, that would, how that could provide access to our systems. But really what we're seeing is that, we can see misuse of other data to impact us as well, right? So for example, data from business wires has been stolen for illegal stock trading purposes, right? There's a risk around aggregated data as well. We think of aggregated data as being kind of somewhat anonymized, or that it's not able to identify us individually. But what we found is that aggregated data was found on Strava and used out of context to identify secret U.S. military sites, right? And so we can't just assume that we can't make sense of some of this other data. And in today's connected and ecosystem-dependent world, the impact of cyber attacks is exponentially amplified. There was the WannaCry crypto worm, right? You might have heard of that one, that exposed an operating system vulnerability and infected over 300,000 computers across 150 countries in just a matter of days, right? And this brought down businesses. It impacted work that was being done, and so on. There was a Mirai malware that was used to hijack over 100,000 IoT devices and then use those devices to launch an attack on a domain registration services provider, right? So attackers can also, we've seen, right? I mean, they can spread fake news much faster than how good news and real news traditionally gets spread. So leading businesses are recognizing that just as they work and collaborate with their partners in the ecosystem around these new products and new services and new experiences, they also need to collaborate on security.
Yeah, so I think for us, it's really critical that we're building resilient and sustainable innovation. And this includes making sure that we're building systems that are secure by design. I think I really love this point around making sure that the whole ecosystem and the supply chain is actually secure. Given how increasingly networked and connected all our world is, I think it was the the designer, Bruce Mau, who said something like, everything is connected. So for better or worse, everything matters. And so to me, that means you are only as strong as essentially and as transparent and as secure and you are vulnerable as your weakest link in the chain. And we've seen regulators in the past kind of put liability not just on you as an individual in terms of your cybersecurity, your secure environment, but also in your supply chain. And we're anticipating that trend as well.
Okay, our last trend, our fifth trend, is called My Markets. And this is all about those momentary markets. 85% of executives agree that the integration of customization and real or near real-time delivery is going to create the next big wave of competitive advantage, right? So again, customization and real or near real-time delivery. And that's all about capturing moments, right? So whether it's real-time views of operations, whether it's instant price quotes based on inventory or scheduling or pricing data, whether it's the ability to immediately adjust and respond based on customer feedback that you're getting, right? Or these pop-up services that we talked about, it's all about capturing that moment. And as we get better at capturing those moments, people and businesses are going to expect more convenience and immediacy from our technologies. And companies can capitalize on these moments by providing personally, tailored products and services that go far beyond just customization. So the example I'll share with you is what Carnival Cruise Lines is doing, right? They're transforming the entire ship experience, right? The cruise experience. And what they do now is everyone will be getting a what they call a medallion. It's a wearable device, and it knows your preferences. It knows, it's able to know where you are on the ship. It allows you to make purchases, right? It does all these things. And they're also adding IoT sensors and cameras and analytics and just all this information all around the ship as well. So that, for example, they might identify that there's availability at an upcoming attraction that maybe your child might like and that they would be really interested in. And then it sends you a message and offers you the opportunity to be part of that attraction, right? It's a very momentary opportunity. It comes, is made available to you, and then it just goes away.
Yeah, so given the criticality of these momentary markets, what I would say is that companies need to really think about how do you establish just-in-time trust? And how do you establish that you have the responsibility so that trust can be established and exchanged seamlessly and quickly? This necessarily means that trust needs to be incorporated in the very early stages of designs. These systems should incorporate, for example, for us at Accenture, we want to incorporate the principles of trust and deploy technologies responsibly. So I talked about trustworthy, reliable, understandable, secure, and teachable. Working through this beforehand really matters. In our global responsible AI survey that we conducted last fall, 24% of the respondents indicated that they had to undergo a complete overhaul of an AI system due to either inconsistent results, a lack of transparency, and/or biased results. And so, what do we do? What does deploying responsible technologies look like? And I just put together some of these points. And I think it's really critical that we're building agile, multidisciplinary ecosystems. If you've got a group of individuals that look like you, act like you, do the same things that you're doing, it's very likely you're going to have some blind spots. We think that companies ought to be looking across the board. You may need to be engaging with human rights organizations for the first time, academia for the first time. Use good data hygiene. I can't tell you how many times it's really important for people to really understand the way that the bias can creep into systems. How do you build a governance strategy that anticipates downstream impacts? How do you create systems of constructive dissent and incorporate diverse perspectives? And how do you use this whole system to enable informed decision making? There's no one tool. I wish I could say, I've got a checklist, we've got this great thing, and it's going to stamp you like organics, and you're going to be ethics certified. There is no one magic solution that will solve everything. Instead, companies really need to invest in these governance strategies. When we started this presentation, we said that we wanted to apply what we learned in the last 5 years. Because in the last 5 years, we've had this immense push forward. The old models of disrupt or be disruptive or move fast and break things were commonplace. At times, this mindset just served as a justification to innovate without implications, without a desire to take into perspective compliance, trust, or ethics. And if I may for a moment just use the EU's General Data Protection Regulation as a watershed moment, because things are being mirrored in California, for example. We are at a meaningful transition right now. I've talked a little bit already about some of the increasing level of activities that we're just seeing in the United States. In Europe and in other countries, there's even more activity. And some are also being demanded by the public. The next 5 years, we think, is about trust and responsibility, and how do we create sustainable innovation. But in the end, we cannot, as we said at the beginning, go at this alone. Instead of separate businesses trying to go their own way, I think we've really got to work together and collectively to try to get this right and pull in the different community interests, the different perspectives, to make them at the heart, genuinely at the heart of the discussions that are happening today.
Okay, so we've given you a glimpse into the future, and we hope that this presentation has provided you with some things to think about when it comes to defining and deploying responsible technology. If you'd like more information on our technology vision, you can visit our website, accenture.com/technologyvision, and you can also connect with both Deb and myself on Twitter and LinkedIn. So feel free to reach out to us with any questions or conversations you'd like to have. And what I'd like to end with is the same question that I started with at the beginning, right? We've talked about how technology can be good or bad based on how it's deployed and how it's implemented. And my question will come back to, what is your role in influencing whether technology is good or bad? So thank you for your time. I hope you found this useful. And Deb and I will be here in case you have any questions. But thank you again, and enjoy the conference.
Thank you for coming. This concludes our session. Please exit the forum to your right as quickly as possible so we may get ready for the next session. Thank you very much.
Please welcome Paige Banks. Bailey. Please welcome Paige Bailey.
Hi, everybody. I was a little confused at first. I was like, oh my gosh, that doesn't sound like my name. So, hello, everyone, though. How are you? No, louder. Like, I am aware that we are feeding and providing caffeination. So, how are you? How is Cloud Next? Are you excited to be here? Thank you. So today, I am super excited to tell you all about Google Cloud and about TensorFlow 2.0. And how GCP developers can benefit from some of the great work that's being done to integrate the two. I'm Paige Bailey. I'm a TensorFlow developer advocate. And in a few minutes, my colleague Lack will come on stage, who's working very, very diligently in GCP, also doing kind of the same thing. So together, we're a tag team that will teach you everything that you would possibly want to know about TensorFlow and GCP. So starting with TensorFlow 2.0. TensorFlow has been wildly popular. We open sourced the product about 3 years ago, and since then it's kind of grown astronomically as a tool and as a framework around the world. Each one of those little orange dots that you can see there on that map is the location of someone who has starred our repo on GitHub. And I don't know why that's like a metric that folks like to cite, but it's the case there. And so you can see it's everywhere from Europe to South America to the United States. And I think I even see a little orange dot in Antarctica, which is, deep learning on penguins. So we've had over 41 million downloads, 50,000 commits, 1,800 external contributors, really proving that this isn't just a Google internal project. It's also something the external community is very, very excited to have too. I believe most of y'all are familiar, but we have been using TensorFlow internally at Google for the last 10 some odd years under various names. And it's been incorporated into our most popular Google products. Everything from search to photos to Gmail, it's all using TensorFlow in order to do its inferencing for machine learning. And you can see there kind of a timeline of all of the different features that have been added over the years. We've taken Keras, which is a higher level API, and we integrated it a while back. We launched our alpha about a month ago at the TensorFlow Dev Summit. And then there are a number of other integrations with TPUs, with TensorFlow Hub, which is kind of a reusable machine learning model component library that you can use for free. And we'll find out all about those later on in the presentation. So as I mentioned, TensorFlow has been very, very successful within Google internally. We are using it to power our data centers and to drive efficiencies there. We use it for localization in Google Maps. We use it in photos. To support portrait mode on the Google Pixel. And the external community has built things we could have never imagined. So here, for example, you can see a code pin that was created by Taropa, one of our machine learning Google developer experts, to create custom beats, to do custom beat generation with TensorFlow and JavaScript. And that's all hosted in the browser, trained in the browser. It's delightful to see. There are also increases in medicine, right? So this is an example from DeepMind, AlphaFold. There's kind of a protein folding Olympics that happens every year. And the first year that DeepMind entered, they were able to blow the researchers' performance out of the water, specifically for protein folding, all using TensorFlow. So historically, TensorFlow has, as I mentioned, it's been very successful, but it was also kind of painful to use. I remember the first time I tried using it in 2015, it felt a little bit like cats scratching your face. Like, it did not feel Pythonic in the slightest, So here, for example, you would have a situation where you define variables, you create a session, you initialize your variables, you start queue runners, and like this, if you're coming from scikit-learn, like this makes absolutely no sense. So with TensorFlow 2.0, we've learned a lot. We've learned that if you're going to create a machine learning framework and you want to expect people to use it out in the real world, it has to have a much more intuitive syntax. It has to be cleaner, it has to be consistent, and you have to have API endpoints that are intuitively named. So with TensorFlow 2.0 Alpha, we've decided to focus on usability. We have tf.keras as the recommended high-level API, though estimators are still around if you've been using those. And we have eager execution by default. So instead of having to create a graph before you can inspect and use it, you can now do things like add two numbers together. Wild idea, right? And you can get a response back immediately instead of having to initialize the variables and then create a session to generate the same response. We've also removed duplicate functionality. So if you used TensorFlow previously, and how many hands are those? How many of you tried using TensorFlow 1? So a good portion of the room. Excellent. I'm sorry. We apologize. I promise it's getting better. But we've removed the duplicate functionality. So if you remember, there were thousands upon thousands of endpoints, many of which did the same thing. We've sort of truncated them and bucketed them into intuitive modules. So instead of having tf.foo, we now have things like tf.math.foo or tf.signal.foo. We've also made the syntax more intuitive, and we've heightened compatibility with the entire TensorFlow ecosystem. So now instead of having multiple ways to save and export a model, everything is a saved model. And that means that it's easy to ingest in TensorFlow Lite and TensorFlow JS. And all you have to do is create something in 2.0 and deploy it to any sort of infrastructure, any sort of endpoint. We've also preserved the functionality of the full lower level API. So if you're a fan of the raw ops that you might have seen before, those are still very much available. But I do want to highly, highly recommend that you start with tf-keras, then try subclassing keras modules before moving into the functionality of raw ops. We've also created inheritable interfaces for variables, for checkpoints, and for layers. And if you have any questions about those, it would be a great idea to take a look at the RFCs that have been posted in the TensorFlow organization repo. So again, just kind of a high-level architecture. We have a variety of tools for doing training, one single way to export a model, so saved model, and then you can deploy to a variety of locations. So TensorFlow Serving, TensorFlow Lite for mobile and embedded devices, including edge TPUs, TensorFlow JS for deployment in the browser. You can also train using TensorFlow JS. And we have several other language bindings, so everything from C to Rust to Swift and more. As the training workflow, if you have experience using machine learning, this probably looks very familiar. Historically, again, it was very, very difficult to ingest data, especially structured data, into TensorFlow projects. Now we have tools like tf.data and tf.data.datasets that make that process very, very straightforward and simple. So for example, if you wanted to load data using TFDS, all you would have to do is assign a variable to that data set, create some sort of ingestion function, and then divide it into training and test sets. So again, if you're from the scikit-learn community or if you're from the R ecosystem, this syntax looks much more intuitive than having 100 lines of boilerplate code in order to just ingest a CSV or a table from a database. We have a variety of data sets that are freely available as TensorFlow data sets. So massive ones that reach search scale, and then also smaller ones that are more typically used for machine learning projects. So for example, the Titanic data set, MNIST, the IRIS data set. But I highly encourage you to take a look at all of the ones that are available on the website. And of course, TensorFlow loves keras. So how many of you have used keras? Somehow there are fewer hands than the number of people that said that they've used TensorFlow, and that breaks my heart. Oh man, okay, cool. So that's everybody's homework for tonight. Your homework is to go and try out Keras. So I mentioned before, I think, that I started using TensorFlow in 2015 when it was first released. And it was excruciatingly painful. And the only reason that I started using it more was because of this higher level API called Keras that was authored by a gentleman named Francois Cholet. And what it does is, instead of having, the confusing, 300 lines of code in order to do a thing, suddenly your project looks a little bit more like this. You import TensorFlow, you assign a training and test data set, and then you can build a model with just 5 lines of code. So again, if you're a fan of scikit-learn, this should look pretty simple. All you have to do is define some layers. If you've taken any sort of deep learning class, you can probably recognize that this is MNIST because there's a softmax layer telling you that this is a classification task with 10 options for output. You can define some optimizers, the loss, the metrics that you care about, and then you go through the training process. And that's all. To build a deep learning network, that is all you need, 10 lines of code. And since we're Google, we wanted to make it scale. And to make it scale, it's as simple as adding 2 additional lines. So with distribution strategies, you can scale across a cluster of GPUs, a cluster of TPUs, a cluster of CPUs even. And it's just as simple as placing your model in a with strategy scope. It's great also to not have to be responsible for doing the entire training process yourself, right? Like, only a few companies have access to massive amounts of data, and deep learning has been proven that the more data you have, the better. So in order to sort of give a leg up on that process, to accelerate the quality, the accuracy, and the training of your machine learning, we've created something called TensorFlow Hub. And think of this as a sort of open source library of models and model components. So Google has open sourced hundreds of their most useful tools, everything from natural language processing to image classification to video analysis, from speech to text, and a variety of languages. And they've made them freely accessible for the public. All you have to do is import each one of those model components into your TensorFlow project, and suddenly you can go from taking 2 weeks to train on a massive data set to taking something like 7 minutes through the power of transfer learning. And I mentioned before as well, for folks who are more used to having sort of highly specific and specialized models, Keras might feel a little bit too high level, but if you need to go a little bit lower, you have the ability to do subclassing. And so this is building a custom encoder for machine translation, focusing on implementing the computational algorithm. You can even customize the training loop to get full control over the gradient computations and your optimization process. And of course, all of this is able to be visualized within TensorBoard. With TensorFlow 2.0, we've even given you the ability to embed TensorBoard within Jupyter Notebooks and within Google Colab. And we've created built-in performance profiling tooling for TPUs and also for GPUs in collaboration with our partners at NVIDIA. We've boosted the documentation. So documentation is always something that people are asking for. Better API endpoint examples, better tutorials, quick starts, things that you can copy and paste the same way that you would copy and paste from Stack Overflow. So we've improved that. And we've also increased the performance. So here are some metrics that might be interesting for folks to go and try out on your own data. We've also added something to the effect of 60 additional projects to the TensorFlow organization repo. So we've come a long way since we open sourced in 2015. Everything from TensorFlow probability for statistics-focused analysis and Bayesian methods, to TF agents for reinforcement learning, tensor to tensor, TF ranking for sort of ranking problems, TF text for natural language processing should be released later on this year, TF federated and TF privacy for secure computation, and more. So if you're interested in anything, in anything you see in the repo, please feel free to drop me a line and to start contributing. You can deploy anywhere, again, mobile and edge devices, servers, browsers. With TensorFlow Extended, we've built an end-to-end machine learning pipeline, everything from data ingestion to training to retesting your model's performance over time to deploying it, and deploying it in a variety of ways. So this was always the most frustrating piece to me as a data scientist, was I would create this beautiful model. It would be written in Python or it would be written in R, and then I would hand it off to a DevOps team to do data science, and they would refactor the entire thing into Java or to C++. And it would be really, really difficult to make any sort of modifications to that model over time, and it would also be really, really difficult to obtain accuracy metrics or to understand kind of the provenance and the lineage of my data as it was going through the retraining process, to make sure that I was training on data that was in the same format, the same type as the data that it had been trained on initially. And TFX, again, it's what we use internally to do all of this end-to-end machine learning process. And it's all completely open source. So if you want to use it, there's nothing stopping you. You can take a look at our GitHub repo and use it on your own infrastructure before deploying it to a cloud infrastructure. I mentioned before we have TensorFlow.js, a lot of pre-trained models there. And again, with TensorFlow 2.0, we're focused on an entire ecosystem of products. So not just something that you can train locally on your laptop, not just something that you can train locally on a cluster, but to any endpoint that you can imagine for deployment, and also integrating with a lot of other tooling. And the question that I'm sure everybody's concerned about, how do I upgrade? Unfortunately, 2.0 code is not synonymous with 1.x. Even if it looks exactly the same, you will still need to make an upgrade. But we've decided to make it as easy as possible for you. And that's because all of our colleagues within Google are also migrating right now at the same time. So if you do it right now, you're on the bleedingest of edges. Yes, so upgrading is as simple as running an upgrade script. All you have to do is take the TF Upgrade v2 tool, define a Python file that you want to upgrade, or a directory of Python files, and then a location that you would like to specify for that output. It does a variety of things, and we'll take a look at that now. So for example, here, you would export a Python file or a Jupyter notebook. Both are supported thanks to one of our machine learning GDEs. You run the upgrade script with TF Upgrade v2, and you specify an output location for that Python file. And you get a report.txt generated from the tool. And it tells you everything from it renamed some of the endpoints. So again, that reorganization process that I was talking about before, where we're cleaning out the cruft. It tells you that it added some keywords to a function called tf.multinomial before it renamed it. And it tells you that it renamed a couple of other symbols to tf.compat.v1, which just means they don't have a one-to-one equivalent within TF 2.0, but you do have an escape to backwards compatibility mode. And then once that's done, you can run the script exactly as you would before. So really, we wanted to make sure that the upgrade process was as simple and as straightforward as possible. If you have existing 1.x models, you should be able to run this and get back something that looks like 2.0. And if you have any questions, confusions, or snags, feel free to file a bug on GitHub and to let us know about it. We have a testing and migration support hour every week at 2:00 p.m. Pacific time, and we would be delighted to have you attend. You would be attending with Google engineers. And we're all delighted to hear about the experience that you're having using 2.0. All of our progress is available online on GitHub as in sort of a public progress tracker. We wanted to heighten the transparency, and we know that a lot of people sort of care about the functionality and when it's going to land. So please take a look at that. And also, TensorFlow 2.0 is all about community. So if you would like to win a free ticket to something called TensorFlow World, or if you would like to present your TensorFlow 2.0 project directly to the TensorFlow engineering team, feel free to take part in our Powered by TF Challenge. The URL is there. And we also have a Udacity course that has been released just recently. So this is 15 modules, completely free. Highly encourage you to go and take a look at it. It was a lot of fun to create. And let us know if anything is interesting to you, or if there's anything else that you would like to see. And with that, I'm going to welcome my colleague Lack to the stage, where he will tell you all about how you can use TensorFlow with GCP.
Thank you, Paige.
Thanks.
Thank you. Thanks, Paige. So Paige mentioned a few things, right? The key thing being that with TensorFlow 2.0, we focused very much on usability and simplicity, about taking the things that used to be very hard in TensorFlow 1 and making them easy. And one of the things that used to be very hard was running TensorFlow models on TPUs. You had to basically rewrite everything. So yes, TPUs were faster, but it wasn't that you could just take your code and run it. Your estimator models being moved to a TPU is very hard. So we're very, very, very happy to say that you can now run Keras models pretty much as is on a TPU, right? So we talked about how TensorFlow loves Keras, so do TPUs. And the cool thing is that with TensorFlow 2.0 being alpha, many of these changes are already available to you in the stable version of TensorFlow. So TensorFlow 1.13, if you're using it today, you can start using some of these things that we're talking to you about, and you can upgrade as TensorFlow 2.0 goes into beta and goes into GA. So why do we need TPUs? And this is one of my favorite graphs, and it's something that you want to kind of understand when we look about machine learning, right? Effective machine learning requires large data sizes. We all know this. Everyone says, yeah, we need lots of data if you're going to do ML. But no one quite tells you what we mean by large amounts of data, right? So look at the x-axis on that curve. That's the size of your data. And the y-axis is your error rate. Error rate goes down as your data size goes up. Cool. But how does your data size go up? It's 2 power 20. This is the translation model, but the same kind of effect holds for other types of models. It's 2 power 20, 2 power 21, 2 power 22. So what's happening to the data each time? It's doubling, right? We're not talking about 10% more data. We're talking twice as much more data, 4 times as much more data, 8 times as much more data. So that's number one, right? So if you're basically looking at you want to build effective machine learning models, you need large amounts of data for anything beyond toy problems. If you're going to be building custom ML models, you need large amounts of data. The second bit, right, is that over time, the way we've taken advantage of large amounts of data is that our models have become more and more complex. So if you look at the size of your model, AlexNet was what launched the whole deep learning revolution, 2013. That was a very simple, like a few layers. And then when we get to neural architecture search, which is a thing that powers AutoML on Google Cloud, the difference in compute is 10,000 times. Okay? So put those two things together. You basically have now 32 times more data, and you're using models that require 10,000 times more compute. That's the machine learning challenge when it comes to running infrastructure. Okay? So that's kind of why you need application-specific chips that are focused on machine learning, and that's what TPUs are. And TPUs version 2 and 3 are available on Google Cloud today, with version 3 providing 8 times the power of version 2. So the idea is that when you want to develop on TPUs, you basically develop with Jupyter, and you just develop in a Jupyter notebook, and this Jupyter notebook is basically running in a deep learning VM, and the deep learning VM is connected to a cloud TPU. And so you're basically developing in your very familiar environment, and you're basically building ML models on those. Okay? And as I said, the models that you're building now can be just Keras. Right? You're basically building TF.Keras models, and they run on TPUs. Okay. So here's an example of a notebook that essentially works the same on both CPUs and GPUs. So here, I'm launching a compute engine instance, and then launching Jupyter Lab. I'm into the Jupyter notebook. I've Git cloned a repository. I've opened up the repo, found the TPU. So these lines of code are different. But once we found the TPU, I can basically take advantage of reading the data. It's all exactly the same notebook. It's exactly how we would write a Keras model if you are running it on a CPU or you're running it on a GPU, with this one difference that we're using a TPU distribution strategy. Right? So where you would normally be using a mirrored strategy for a GPU, you can now use a TPU distribution strategy. And where you would normally call model.fit, I'm calling TPU model.fit. It's exactly the same Keras kind of code. Right? So you write your Keras code, and the same notebook, we're now going to basically change it. So it's all of the same stuff. And then I'll go ahead and shut off the TPU. I will launch this whole thing on a GPU machine and start this whole thing again. And now, at this point, the TPU part is done. It has trained the model. It's done image classification. I'm shutting that off. I'm starting a GPU at this point. I'm reloading that notebook. And this time, I'm just running it 10 times faster, right, just to save time. But the idea is that the exact same notebook works on both GPUs and TPUs. So that essentially makes that you have the ability to run extremely fast things faster. So why would you use a TPU, right? One of the cool things is, normally when you go from one GPU to a second GPU, do you get twice the performance? No, right? Why don't you get twice the performance? Because there's some network overhead, and so you don't get, so if just because you put 40 GPUs in a job, you don't get 40 times the performance. You tend to basically start plateauing because the network overhead starts to take over. The cool thing about a TPU is that even though in that notebook we showed you running it on one GPU versus running it on one TPU, you can basically expand this out to running on 128 chips on 1/8 of a TPU pod, or go up to half a TPU pod with 512 chips. And you basically get linear performance because of the interconnect within the TPU. Right? So the real benefit is basically driving back to the first point that we made, that where effective machine learning requires extremely large amounts of data. So you need to basically get a pipe of data that's coming in, and you're able to read it very, very, very fast. So you're able to use much larger batch sizes and basically get more accurate models. And not only get those more accurate models, get much better performance on it. Okay. So this is basically the end result. So if you basically take a full TPU pod, you basically get about 200 times the performance of a GPU at lower cost. And the cool thing now is that with the simplicity of TensorFlow improving and the ability to use Keras models, you're able to do Keras models on a TPU. The second big aspect is what Paige also kind of talked about, the TensorFlow extended. So we talk about machine learning, and we basically talk about the machine learning model. But the machine learning model that we build is just one part of a much larger pipeline. And as we talked about, we don't want to have to go rewrite everything in order to put it into production. So the way this is done at Google is to use TensorFlow Extended. And we published a paper on this back in 2017 that was about how we build a TensorFlow-based production system. And the key thing is that there is a trainer in the middle. That's the machine learning code that we all talk about. But before that, you have pre-processing and you have validation. And after that, you need to evaluate your model, and you need to serve it. All of these components form the production system for building and deploying TensorFlow models. Last year, we had already open sourced a few of these things, right? And some of the parts around it, like the tuner, is a hyperparameter tuning that's part of our AI platform. It's part of our ML engine. Logging is provided on GCP by Stackdriver. We had also open sourced the transformation, which was TF Transform, which on GCP you can run at scale using Cloud Dataflow, and we had open-sourced TensorFlow Serving, which is how you take your saved model and you deploy it, and you basically can do that on our AI platform using predictions, using ML Engine. So you basically have the open source aspects, and you have the ways to run them on GCP. So that's what we had last year. Now this year, we basically have also open sourced the validation piece and the evaluation piece. And of course, the number 3, the trainer part, was a TensorFlow model that was always open source, and you could do it. But at this point now, the entire TFX pipeline is open sourced, and you can run it at scale using managed services on GCP. So let's quickly walk through those. Okay, so to kind of say, what are these? Let's say, for example, a validation piece. Let's say you're doing a healthcare data set, and you have a column named last diagnosis. You might want to say that this last diagnosis is an ICD-10 code. An ICD-10, like, there's a bunch of different healthcare diagnosis things, and each of this has a particular vocabulary. And you might want to be able to say, based on my data exploration, in my training data set, about 3% of this is invalid. Right? You basically explored your data, and you found that that is the case. At production time, what you can say is that now this is my schema that I've discovered during the data validation by looking at all of my training data sets, and we can basically provide a threshold. As long as during serving, less than 5% of the inputs that come in are not in my vocabulary, it's okay. But everything that's not in my vocabulary, write it to an anomaly place. And then we can monitor these anomalies so that if the vocabulary ever changes, people start putting in new diagnosis codes that you don't know about, you now know about it because they show up in these anomalies. That's the point of the data validation piece that you put ahead of your pre-processing. Okay? And the way this works is that, again, this is the first part of the TFX workflow. We're basically going ahead and getting the data set, taking the data, this is the training data and the validation data, and then we're basically importing TensorFlow data validation and using that, and this is just a CSV file, and I'm basically doing generate statistics from CSV. Right? So basically reading all of these files, telling the TensorFlow data validation to go ahead, and in this case, I'm asking you to sample just 10% of the data. Obviously, we can do the sampling fully, and this is a Beam pipeline that runs on Dataflow and creates this graphic for us by looking at all of the columns and basically computing statistics, giving us quantiles, giving us a distribution of these, how many of these are missing in the training data set. Right? And we do this for both the numerical data, we also do it for the categorical data. In this case, the origin, it's a flights data set. There's like Atlanta is the most common airport. We take that data, and if you have some data that has a vocabulary like the carrier, it knows all of those vocabulary items. It takes all of those things and saves them in the schema, and we can basically go ahead and take the schema and save it. And this schema can be used later on during the production workflow as well. So this is the schema that you're creating from your training data set, and this schema is basically going to get used as part of your production pipeline to know when there's an anomaly that has happened. Okay. So the next bit, once you've done the data validation, is to do the pre-processing. So you're basically going to, and this is something that we've seen before, where we take our data and we scale it, we find the vocabularies, we do one-hot encoding of it, and that is with TF Transform. And in this case, for example, we may say that we have our aircraft data, and we may have like airports. What are the airports, and how do you one-hot encode them, et cetera? This is TF Transform. It's exactly what existed before. Okay? So in this case, I'm basically creating a pre-processing function, and unlike the data validation, in this case, I'm explicitly showing you the Beam code. So we have helper functions to make it easier, or you can basically write the Beam code yourself to basically do things that are much more customized. But in either case, you can run the pipeline on Cloud Dataflow. And at this point, you basically have a pre-processed data with the results of this pre-processed data being written out. So the TF Transform writes out the transformed trained data. It takes the test data, writes the test data also out, and it writes out the transform artifacts. How should I scale the input values? What are all the schema values that come in? How should I know that things are anomalies? that I need to know about. And all of those are now stored, and they can then be used to basically train your typical model. So that model, again, the training is exactly the same. In the interest of time, I'll skip that, and I'll move to the next bit, which is after you've trained your model, you want to do your model analysis. How does that look like? So in the model analysis case, I'm basically saying that, OK, so this is the last, the part 4 of it. And I'm basically doing the model analysis where I'm saying that I want to slice the output of my model based on certain attributes. I want to see, is the accuracy of my model, does it vary depending on which airport we are flying from, right? So I'm basically going ahead and running the evaluation, but I'm now doing the evaluation not on the entire evaluation data set, but in various slices. Okay, so watch for that. The slices will come up in a little bit. Okay. So I'm importing the TF model analysis and then preparing the data slices for evaluation. Right? That's the next thing that's going to happen. Okay, right, there's a slice spec, and I'm saying that I want you to slice the evaluation by the origin field, by the destination field, and by the carrier field. So I have 3 different ways that I want you to slice the evaluation, and then when I run my evaluation, I'll basically get metrics for each airport that is an origin, each airport that's a destination. And obviously, this depends on your data set, right? You can slice it by customers, you can slice it by country, you can slice it by different kinds of scenarios, and you can basically monitor how well the performance is. And the result is basically you can go ahead and visualize those rendering results. So that's basically the model analysis bit. The last part is serving the saved model, and that remains exactly the same. We have a G-Cloud way of basically taking a saved model and serving it out for predictions. So that part, again, it remains exactly the same as we used to do before. You say G-Cloud ML Engine, create a version, go ahead and deploy it for prediction. You send in a JSON input, and you get your predictions back. But the cool bit is, now that this deployed model takes advantage of all the pre-processing, takes advantage of all the data validation steps that have been done, and these anomalies are getting written out so that you can go ahead and monitor them. So basically then, right, this entire pipeline is now all open source, and it's available to be run at scale on GCP. So as a quick summary then, right, what's new in GCP and how do GCP developers benefit? Number 1, to summarize what Paige talked about, TensorFlow 2.0, you get eager execution, a lot less code, you get to use TF data pipelines, you get to reuse TF modules, and you get to use distribution strategies in Keras. And you can try out TensorFlow 2.0 alpha on our notebook instances, right? So you can basically launch Jupyter on GCP, try this thing out, and it's very easy to migrate from 1.x to 2.0, right? So you basically have that upgrade script. So you can use that as a start, and over time, you can change the things for which there is no direct one-to-one mapping, the things for which we do tf.compat.v1. tf.compat.v1 will continue to work in 2.0. It's not that you have to change it immediately, but it's going to be a best practice for you over time to remove the compat.v1 from your code. Second big improvement is the cloud TPUs, right? So we basically have, the cloud TPUs are hardware accelerators for TensorFlow. They're faster, they're less expensive, and much more scalable than GPUs. And the really cool bit is now you can write TensorFlow models for the TPU, and those models can be written in tf.keras. And that makes it much easier, and as we showed in the demo. And it's available on notebooks, it's available in ML Engine, it's available in Kubeflow pipelines. You can access your TPUs from all the different environments from which you can run ML models on GCP. And lastly, TensorFlow Extended, which basically builds out an ML ecosystem beyond just the training piece. Now you have data validation, you have pre-processing, we have serving, and you have model analysis. We've completed the story now, where last year we had only 2 pieces of it. Now we basically have completed it. And you can take advantage of that to run things at scale using Cloud Dataflow and using Cloud ML Engine. And again, it's available on Kubeflow pipelines, and it's available on Airflow. Thank you. And That's our Twitter feed, right? So I'll make sure to tweet the links to my demo GitHub notebooks. So follow me on Twitter, and you will get the link to the notebook if you want to try it out. We really appreciate your feedback. So please go ahead and complete the session survey in the mobile app.
Turn the lights down, we can throw a house party. All we need now, a little fun and a little money. We can do anything we want now. There's no rules, we invent the groove. Let's go, beat and let it flow. No one ever gonna
All right, we're going to go ahead and get started. So if everybody could take a seat if you don't have one already. So thanks so much for joining us today. We are here to have a really great conversation around AI and responsible use of AI. I'm going to start. I'm Tracy Frey. I'm the Director of Strategy for Cloud AI. I'm going to start with just a few slides, a little bit of history, a little bit of future, a little bit of everything. Before we then have a conversation, I also just want to make sure I introduce our fabulous panel that we have today. So we have David Knott, who is Chief Architect at HSBC, Jay Yagnik, who's a VP at Google AI and Fellow. And then we have Nick McGuire, who is the Vice President and Head of Enterprise Research at CCS Insight. So you're going to be hearing more from them in just a couple seconds. So I wanted to start because part of a question that I get all the time is around how come the mixing of things like ethics and technology. And the reality is these things have been mixed for quite a long time, really since its inception, because the story of AI actually doesn't start with technology at all. The story of AI really starts with philosophy, with thinkers like Lull and Hobbes and Descartes, all of whom really wanted to apply order to thinking. You can see Descartes really wanted thought to be as systematic as something like algebra or geometry. And there was this vision that in the future, machines could help with this sort of ordered thinking. You could see some of this actually in where we take inspiration from biology. And this is really the basis of neural networks, is in fact the neurons in our brain. This diagram shows how the neurons in the brain, and they send out all their signals through the dendrites. Those are sensors, right? This was inspiration in many ways for the Turing machine, which is an interesting concept if you're not really thinking about how some of these things come together to really make AI what it is today. From the 1950s into the mid-70s, right around my birth time, we had the both hyped AI winter. So this is an image of the perceptron that was built in 1958. What you can't see in this screen is a 2020 array of camera lenses. And this was, these were the camera lenses were meant to be the eyes. This thing got so hot that you could fry an egg on it. It was larger than a Sub-Zero refrigerator. But it didn't work. The goal here was to create a machine that could perceive something. You could show it an image of something, and it could then tell you what that image was. Because this didn't work, there was then really no funding for neural networks for almost 10 years. This started to change in the 80s with new advances in physics and math. Folks like Jeff Hinton, who's now at Google, and really understanding things like backpropagation. And this really started to change the game and bring us to where we are today and what might be possible with AI today. In the 1990s up through the 2000s, the big change that happened was a massive improvement in computing power. So everyone here has probably heard of Moore's Law. What's crazy here is that it really just continues, and we're actually going to talk about that in a moment, and how that is specific to machine learning. One of the things that computing power has enabled is for the technology to get far more sophisticated. So in 2011, the field of computer vision had about a 26% error rate. In contrast, humans had about a 5% error rate. Fast forward just 5 years to 2016, and at that point, computer vision has a 3% error rate. In many ways, more capability than the human eye. That is a massive change in a very short time period. And this brings us, in many ways, to where we are today, where AI is now capable of doing so many things, and that makes it even more important that we spend the time to really think about how we are going to use it in our organizations. When I think about the rise of the internet and how much that changed everybody's lives, and I went to college at a time when the internet didn't exist, and if I think about trying to do that again now, it is pretty much impossible. And when I think about what I've seen from what AI can do for enterprises, for consumers, for the world at large, we really are on the cusp of something very, very similar. Coming back to Moore's Law for a second, there are over 90 machine learning papers published per day. It is outpacing Moore's Law. So the capabilities here are growing at an enormously rapid clip. And that's been the case for Google as well. So over that time period of the last 5 to 7 years, Google has really transformed itself into an AI-first company, which is something you hear from us a lot about how we see the world. It is really now infused in almost every part of Google's business and has made some of our most powerful technologies that everybody most enjoys possible because of how much machine learning has become a part of what they do. AI has incredible capabilities to do phenomenal things for the world. Some of my favorite examples are things like being able to find manatees, sea cows, from a very high altitude. And if you've had the chance to look at what some of those images actually look like when you're taking a picture of the ocean, it's impossible to spot that manatee, and yet machine learning can do that. This example in the top in the middle is of a group of Japanese farmers who created a cucumber sorter using TensorFlow. So this is not limited to the world of enterprises who can hire data scientists. It is really available to everybody, and this is something that we spend a lot of time thinking about in Cloud AI, and something that we're really excited about. The more products we offer, the more enterprises who work with us, and the more that we can really do with companies around the world. AI has the potential to really help humans make more responsible decisions. So in 2015, this is an ongoing partnership, but this example is from 2015 specifically. We worked with the Gina Davis Institute. We reviewed 200 films and analyzed them for both speaking and screen time for men and women. Really interesting things came out of that study. The first is that women-led films made 16% more at the box office, and yet men were both seen and heard twice as much as women on screen. So you can think about how this can help really drive responsible decisions and create better business value for organizations, because those organizations could be making significantly more value should they have better equality. And that would then help set the stage for everybody to have the potential to see themselves in the future in media. Sometimes issues with bias in machine learning can really also help highlight how bias can be quite systemic. So this study was of 3 million English words from public news sites, from Google News, and it generated he-she analogies. So for example, if you were to use, if I were to say to you to France as Tokyo is to Japan, and if I said king is to man as queen is to, right. So you would expect to hear Japan, you would expect to hear woman. And this is measured by so what this study did was it looked at those distance between words and then applied he-she analogies to those. So for example, you would say she is to sewing as he is to, and the answer that comes back is carpentry. She is to housewife as he is to shopkeeper. She is to nurse as he is to surgeon. So this can really help show just how pervasive and systemic some of those biases are. And that gives us the ability to take a look at that and say, okay, that's not exactly what we mean. How do we fix that? One of the challenges with machine learning is that these mistakes, if they happen, can propagate very, very quickly. So if, for example, in these two images at the top, it's not perceptible to the human eye, but when you mislabel it as a fish, you can see what happens, that suddenly then all of these images of dogs get labeled as fish instead. And these are the kinds of things that if a mistake like that happens, it can happen at great scale and with great speed. And so it's very important to be cautious. Part of my job for Cloud AI is to look after the process we've built to support building our products in alignment with the Google AI principles. The rest of my job is around how can we make Cloud AI successful? And that's around how can we make it so that enterprises around the world really love our products and want to use them over and over and over again. I see these two things as intimately tied, because really when AI is going to be successful, it's because it's going to be trusted. And in order for it to be trusted, it has to be trusted by organizations, by their employees, and by all of their customers. And so for me, a large part of what is going to make AI successful for any organization is when it's responsible. Last year, Google released our AI principles, this set of 7 things that we believe AI should do, and 4 areas that are applications that we said we would not pursue ourselves. And this is something that we spend an enormous amount of time really diving into on a regular. All of our products are built in such a way that they are fulfilling as much of this mission as we can. And we spend time together looking at all the different things we can pull in to ensure that we have alignment with the AI principles in the products that we offer. Some things that we think a lot about when we talk to customers are around taking a human-centered design approach, and we have a number of resources available for how we might do that. We talk a lot about how important it is to really know your training data, and not just what's in the data, but to be thinking outside that, around the sociological effects, around some of those systemic issues, because without thinking about what is showing up in the data before it even gets into your systems, it's impossible to really be thinking about unfair bias in a way that is really robust. In order to help with that, having interpretability and explainability, making sure that machine learning can be understood, both what's in the data and the decisions that it's making, and this is an area where we're spending a lot of time. You can see some of the outcome of this. This was an example from Google Translate with Turkish, where instead of making an assumption that he is the one who is the doctor, offering different options between he and she. But even this is something that is not enough, because that is not a gender-neutral experience. And so how do we then expand on what we're already doing as we learn more? Because the reality is, this is not something that anybody can get 100% right. This is something that we all do everything that we can, and we learn as we go. And we are always learning from our customers, from our consumers, from each other, from all of the exciting research that's available. This you can see also in some where, again, some of those systemic biases showed up. So an internal research scientist discovered that when typing, "I am meeting an investor next week," the next suggestion was, "Do you want to meet him?" And so instead of making that assumption for somebody in Smart Compose, Smart Compose doesn't use gender-based pronouns in their suggestions at all. And until we are in a situation where we may be able to actually accurately predict exactly what that person is intending, that is something that would remain. Biases in data can come from a number of different sources. They can come from biased data distribution, from representation. Are really, really important to take into consideration as you are building and deploying machine learning models. One of the things that we've made available is the What If tool that allows you, and we won't show this video here today, but I encourage everybody to find it online. But this allows you to take different viewpoints, and a model is reacting from different characteristics. As we built our governance process in cloud around how we want to support the AI principles, there were a number of things that were really important to us to ensure that we built for. And one here, but is actually extraordinarily important, is that it shouldn't be dependent on the people who are currently undertaking this process. So for me, it's very important that this is something that lives on at Google because it is rigorous enough who are currently in cloud AI in order to know how to go about doing it. So it was really important for us that it be very, very rigorous, engaging, that it's efficient. We're all very busy. We want to make sure it's a good use of everybody's time, and so that when we have the conversations, everybody has done all of their homework already and is ready to sit down and discuss what's at hand. That they're effective, that it leads to tangible outcomes and improvements in our products, and that they're balanced in understanding both the needs that are out there as well as the requirements of any business. We talk a lot about how technology is most powerful when everyone can use it, but really at the end of the day, it's even more powerful when everyone can benefit from it. And this is the vision that we are trying to accomplish within Cloud AI. And with that, I would like to turn it over. We're going to have a discussion with these folks here. So sit back down. I'd like to start with both David and Nick. As Jay and I were talking about this panel and preparing for it, Jay had an excellent question, which is that, you know, from within Google, we are experiencing AI from the demand we hear from customers. And it would be great to get a sense from both of you about the on-the-ground reality. What is it like to be experiencing the AI wave happening, both from within an organization and from an analyst perspective?
Okay, so thanks very much, Tracy. So I think the way I reflect on it is to say that I think we experience it at HSBC as a large traditional bank somewhat differently than you experience it in Google. You know, we don't do original research to develop new ground-up technology for AI. So we're a consumer rather than an inventor. What I'd say is that consumption is kind of turning up to us in three ways at the moment. Firstly, it's turning up through platforms like Google Cloud Platform. So that has done a huge amount to enable us to have a place where we can put data, operate on it at scale, and have access to a bunch of trainable models through APIs that dramatically lower the bar for us in terms of skills and capability. I think that the way I tend to think of about 10 years ago, we would have had to hire a bunch of PhDs. You know, 6 or 7 years ago, we would have had to hire the PhD students. 4 or 5 years ago, we would have had to hire really red-hot, world-class AI engineers, and now we can retrain our developers and engineers to consume AI and build from scratch. So the cloud platforms are making a huge difference to us. The other two categories we're seeing, though, are we seeing, apologies to any sales guys in the room.
There's none here, right?
Yeah, there's no salespeople here,
Just
surely.
to be sure.
You know, I get sold a lot too. You know, so as chief architect of the bank, I get to make some choices about what we buy and what we don't buy. So lots of people want to sell things to me. I'm seeing a phrase that I learned from Nick a little while ago: AI washing, AI toothbrushing, where products that have got some degree of modeling or analytics in there have kind of had the AI label stuck across them. And if you are selling that, please stop doing that. If you have real AI built into your platform, I'm all ears, but please make it real. So I'm seeing, and I think that's indicative of there being some hype in the marketplace right now. Then the third category I'm seeing is our direct engineering consumption of open source frameworks. I think our perception is still that there's been a huge advance in the platform space, you know, places we can come and build models, test models, validate models, consume AI. I think the domain-specific space, you know, solutions that are specific to financial services, is still quite thin. So we're having to build that ourselves. We don't mind building it ourselves. Again, if you're out there and you're a product company and you want to do something interesting, then solving a bunch of problems in financial services and bringing them to us as consumable solutions would be great. And then my final thought is that I still think we have a big, I'd say we have two problems. One's an education problem and one's an imagination problem. The education problem is, I think, that for most people in large enterprises that, again, are different demographic to Google. In Google, you're mostly engineers and technical people, people with a technical background, and people who don't understand AI will feel compelled to find out what it actually means technically on the ground. Most of the people working for our company aren't technical people and don't necessarily have the propensity or the skills to go deep into what the technology actually means. So AI is just a term, and they will see what happens in the press or what gets presented to them as salespeople. So it's a pretty vague term that could mean a lot of things. So grounding, for our people to ground themselves in what actually means and what it could do for our company is an education problem. The other problem is the imagination problem, where I think actually quite often people, when you explain to them what the current generation of AI really is, they feel slightly disappointed. It's like the magic's gone away. It's not some big brain in the cloud. There's models and algorithms and data, and there's still hard work to be done. So then the imagination comes in, which is actually, well, how do you put together that core predictive capability and use it to solve business problems? So we're tackling both those things, but I think it's still really early days. We are enormously excited about the potential. Our space, banks are all about data. Our space is a rich opportunity space for deployment of AI. We're really just getting started.
Yeah, I mean, it's fascinating listening to David speak. First of all, thank you very much for having me on the panel. I'm privileged in the sense as a research analyst, I get to sit in between the kind of maelstrom of customer requirements and researching customers and speaking to customers around AI and ML on a regular basis. We also do quite a lot of survey work as well, get up to 700-800 companies across Europe and the US every year. And we also look at employee attitudes as well. So we can kind of cover that space, but we also sit in between the big cloud companies and have their views of the universe. And really settling all that down is really kind of speaks a little bit to what David was saying. I mean, what we see out there, first of all, is that our statistics tell us anywhere between kind of 60 and 70% of large businesses that we survey around usage of AI and ML have some form of project, research, or proof of concept. These types of things, actually a percentage of them are actually in production grade with certain applications as well. So, and we've seen that grow quite substantially over the last couple of years. So there's a lot of interest and there's a lot of thirst for knowledge and there's a lot of gravity, obviously, and many of you here in the room will attest to this around AI and ML at the moment. But I would classify the market as still very experimental. We see a lot of companies that are just starting to learn. They're starting on small projects. They're picking use cases where they can kind of start small, get quick wins, iterate and learn, and go beyond into that arena. But what we're starting to hear more of, though, are companies saying, look, how do we take these kind of small experimental engagements and how do we think about a world where we've actually embedded machine learning capabilities into our organization, into many business processes? And that's maturing the requirements that we're seeing. In the last 12 months in particular, when we ask customers, okay, what are your real barriers and requirements for AI inside your organization? And 12 months ago, we heard a lot of around to the point that David's making. We heard skills, challenges. We heard, make the tools simple. We heard use cases, like I want to be able to apply this to my business. We heard data problems in terms of preparatory work and so forth. Those challenges are still there, but what we're now starting to see are companies asking questions about risk. And a lot of the questions and a lot of the points that Tracy was raising are bringing up questions around, okay, how do I address security? How do I handle compliance in a world where this is embedded into my operational processes? And I think most of all, probably the top question we're hearing now in the industry, and I think the hyperscale cloud companies are coming to this now, is around transparency and explainability. How do I lower my dependency on black box AI? And how do I actually create and have instrumentation into my tools that allow me to start to think about how I build interpretability? And more importantly, to David's point, it's not necessarily about interpretability to the data science teams or to the developer teams, which obviously are leading projects at the moment. It's more about the business. How do I get the business engaged in supporting the technology? And I think those are the questions that companies are grappling with now, which is slightly different than say 12 to 18 months ago.
It's interesting with one of the things that's making me think about is we talk a lot about how because AI has really only been able to be used by a relatively small part of the population for the last 60 years, that's created a situation where there are really a lack of enterprise examples, because organizations that have been able to leverage AI can do that because they've been able to hire in that scarce talent. And then it becomes something where it's very proprietary, and so nobody who's on the outside, because those solutions have been built bespoke in-house, has any sense of exactly what's happening. And in hearing you talk, I'm thinking about how that's actually now the experience, both at a macro and at a micro level. And it's making the requirements and need for AI to be far more explainable even more important, because you need to be able, now that you can start to understand how to use it, if you're still unable to understand what it's doing and how it's doing it, and if it's doing it in a way that you feel after you've assessed is rigorously ethical and is being deployed responsibly, if you can't understand those things, how can you trust it? So to Jay, you've been at Google for 14 years, and I would love to hear, and I imagine others would love to hear as well, how have you seen machine learning change over that time, and particularly with regards to issues of fairness and bias?
Sure, happy to talk about that. A little apology in advance. I've come down with a little bit of a cough. Perfect day to have it, when you're speaking with an audience. So if there are brief interruptions, apologies.
If only there were a robot that could speak for Jay or something.
Don't make him laugh.
Yeah,
Don't
sorry.
make him-
we were just joking about this earlier. Back when I joined Google about 14 years ago, we could actually fit everyone in the company who had some background or spoke machine learning, AI, computer vision, pattern recognition in a room much, much smaller than the room like this. Right? So it's been great to see that journey, and I kind of compare it to phases of technology adoption. There are various models out there, but all of them roughly fall in this 4 or 5 phase categorization, which is that you have an early adopters phase, followed by late adopters, early majority, late majority, and laggers. Right? And they follow this kind of a normal curve of sorts. And when you are in the early adoption phase, the kind of questions that get asked, the kind of projects that people find exciting is very different than the phase after that and the phase after that. And this has been historically true for almost all the fields, and I think machine learning is no exception in that regard. Back at Google, whenever we used to have leadership gatherings, I remember a decade ago, people would walk up to me and their favorite question would be, when would computer vision work for real, or name your subfield of AI, sorry, when would that become real? And then starting a few years ago, when people walk up to me in these gatherings, they usually come up and say, here's Google Photos, it misclassified this picture, it didn't catch the dog. Right? And to me, looking at a 10-year period and how the nature of the question changes is actually a really good reflection on what's happened in the field underneath. Right? Is that we effectively went from taking this as maybe it will work someday, sounds interesting, intellectually curious, to as you enter into the kind of late adopters, early majority side, right? This question about quality, reliability, security, fairness, transparency, all of these things, it seems like they come out of the blue, but actually no, they are completely expected with regards to the adoption curve here. And at Google, we have tried to anticipate a lot of this. The reason we came up with AI principles is we felt that as an organization that was in some way leading the way in this field, that what we set out as the kind of operating principles as well as what we draw awareness to will have transitive effect kind of elsewhere. And if you look at different aspects of the principles, we draw out things that we feel we really have to make progress on in order to make this early majority, late majority part of the curve, right? Which means that AI and machine learning will gradually start to become critical part of societal processes, like be it companies, be it governance, decision making, and so forth. And there all of these things become really important. And that also explains why if you look at ML fairness, it almost didn't exist as a field 10 years ago. Right? And it started to become a field 5 years ago, and it's kind of rapidly on the rise. And I fully expect that about 4 or 5 years from now, it will be a big field with kind of more mature cadence of its own. So that's kind of the long-term view of things that we see.
Great. So, David, something that many people may not know about you is that you have a background in philosophy and a PhD in ethics.
Yes.
Can you talk about how the combination of technology and philosophy has helped both your thinking about ethical implications of AI and then how that's impacted HSBC?
Yeah, thanks very much. So I think if I follow Jay's lead and say probably the number of people who've studied ethics academically and studied AI could probably fit in a much smaller room than this. There's probably a phone booth outside somewhere we could all have a convention in. So I think the way it's impacted my perspective is that it brings to me probably two concerns and a hope. So my first concern is that, you showed your graph of the speed at which AI is developing, the Moore's law curve. Philosophy does not move on that curve. In case anyone knows, most of philosophy is having arguments with dead people who framed their arguments over 2,000 years ago. So I regularly have arguments with Aristotle. So that is not just, obviously most of us don't live our lives as philosophers, but that's an indicator of the speed with which our general ethical thinking moves. It does not move at the same speed as technology is changing at the moment. So my first fear is that AI and other technologies will outstrip our ability to respond ethically to them. The second fear, and this definitely comes from my background as both a 30-year veteran of doing enterprise technology, background as a software engineer and as a business person, and as a philosopher, is that in engineering and in business and in architecture, which is what I do for a day job, we are problem solvers and solution builders and optimizers, and we look to optimize outcomes. And that's our normal mode of thinking, that's our normal mode of approaching problems. And my belief is that it's not the right way to approach ethical problems. It's not actually normally a helpful way. And just to illustrate this, if you indulge me for 30 seconds, there's a famous philosophical problem that gets written about a lot at the moment in the field of AI, and particularly in the field of autonomous cars. Many of you have probably heard of it. Who's heard of the trolley problem? Yeah, quite a few people. And again, 10 years ago, probably no hands would have gone up. So those of you who don't know, the trolley problem is remarkable. We're in San Francisco because it's one of the few places in the world where this actually is still the trolley problem.
And the Cable Car Museum is amazing if you haven't gone.
Yeah, because most places don't have trolley cars or cable cars anymore. So the idea is, the thought experiment is, you're in a street, there's a trolley car coming down the street, it's out of control. Further down the street, unaware, are 5 people, and they will get run over and killed by this out-of-control trolley car. Fortunately, you're standing by a switch, and if you pull the switch, you can divert the car onto another track. But the problem is there's one other person on that other track, and if you divert them, it will definitely kill that other person. Now, normally when you present this problem to engineers, at this point, everybody starts inventing solutions and ways around it, and could I throw myself in front of the car, and blah, blah. So you can't change the thought experiment. You either kill 5 people or you act and kill 1 person. Now, I'm quite pleased the thought experiment is in the wild now, and people are talking about it. My worry is that I think people are approaching it in the wrong way. They're approaching this as an engineering problem. You can see lots of people turning up and go, oh, great, okay, I've got this thought experiment now. 5 greater than 1, save 5, kill 1, good, job done. Right, now design my autonomous car. Now I just need to know this number is bigger than that number. The point is that's not the point of that thought experiment. The point of the thought experiment is that maximizing is not a simple thing to do. Choosing to pull that lever and kill the other person carries ethical weight. And it's not a simple thing. It's not a straight numbers game. So the thought experiment is designed to express the complexity of ethical thinking. But my worry is that right now it's turning up and people are treating it as if I could just solve this problem, figure out which number is larger than the other, then we can go on and design our models. So that's my second concern. My hope is we're having this conversation. So this is an AI ethics, AI responsibility session, and it's full house. That tells me that people are genuinely engaging with this topic, and engaging with the topic thoughtfully is the first step. To me, the other analogy I have is with unconscious bias training, in helping people to understand diversity and the biases they carry. Unconscious bias training does not remove unconscious bias. It just makes you aware of it. You pretty much can't remove it because it's kind of part of our neurology. ethics training, conversations about AI ethics do not solve all ethical problems, but at least they remind us all those of us who I should imagine a lot of people in this room are trying to build solutions, that we are operating in a context with ethical weight. You know, the things we choose to do have ethical consequences. So the fact we're having the conversation gives me hope. And then finally, to answer very briefly your question on how's this affecting HSBC. So I've tried to have this, I have had this conversation at HSBC. We have, in developing our own set of ethical principles, been thoughtful about the fact that the banking equivalent of engineering is kind of compliance. And you could write a set of compliance type rules that people could comply with. And the problem with that is that would treat this as a solved problem and just give people a set of rules they could follow. The point for me is this is not a solved problem by any means. So our principles, the same as the Google principles, are really starting points for engagement and thought. And that, again, that gives me hope. So that's the way we're trying to approach it.
And just to put a point on that, I'm just curious, how many people in the room have tried to create a long list of these are the things that are okay and these are the things that are not okay from a AI and ethics standpoint, right? So it's not a small number of people who've tried to do that because it's very tempting and it's really attractive to have that nice list that can be just a decision tree for your organization. And to your point, it's impossible.
Yep.
And that, so it is about then the conversations that you have and what you do about the conversations that you have and the issues that surface from those conversations and how you apply ethical thinking to those. That's where you can make a difference.
I mean, if I can jump in on that, I mean, one of the things that I am seeing, and it is, to your point, it is an iterative and it's an ongoing conversation, but the ethical question, these are macro kind of societal questions, but down in kind of the traditional enterprise, solving a specific problem with ML, I think when companies start to think about governance to the point that you were talking about, the whole process of principles comes in. And I think one of the things that we've said, and we've seen some companies kind of say, is that, look, if we can start with our company values and we can start to design things based around our, first of all, risk profile,
right.
You know, and secondly, the values of the organization, that can get us moving into those areas. I think you can get stuck way up here, and I think that is an ongoing discussion that's absolutely critical and fascinating. But the company, you know, principles and values of the organization, that's always a blueprint. It's interesting to see now with yourselves and some of the other technology companies actually putting out their principles, which are linked to their company values, as kind of indication and help for companies doing that as well. So just a thought in terms of how we've seen
now
companies
worried
tackle.
you may have sneaked inside our organisation, because we haven't published our principles yet, but actually principle number 1 is act in accordance with our values. Because we're a very strongly values-driven organisation. We said, look, this is novel technology and it raises some novel moral problems, but actually our grounding in our values stays the same. It's been the same for a very long time and we're not shifting from them. Just have those in mind when you're making choices about how to deploy this new technology.
Yeah,
100%.
It's one of the things we did. I mean, I think Google is quite clear on its core values, and that's something that, you know, we, as a group that works within Google, feel strongly about. But even as Cloud AI, we took on a process to understand what are the core values of the individuals who work in Cloud AI as an organization. And when we do that, what does that mean? How do they relate then to the core values of Google? And just to ensure that there wasn't any mismatch, which good news, there wasn't. But being able to have that also to then build our own processes on top of was extremely helpful.
Right.
Because it was specific to us as a group.
Yeah, I want to add just a couple of things
please.
based on what I'm hearing. I mean, I really agree with David on the part about not rushing to come to a spec for compliance.
That's right.
Because what the behavior that entails is that it gives us a false sense that we actually know exactly what we are optimizing against.
Right.
And whenever you have a compliance spec, like any logical system optimization will optimize the system right up to the boundary condition. Right? And then it's a debate on how do you move the boundary conditions. So I think we very much have to treat this as an open, evolving space and don't over-specify in places where we shouldn't.
That's right, which is uncomfortable. It's an uncomfortable
it
space
is.
to be in, where because there isn't an end.
Yeah, but I think there is also an opportunity, which is the second part of what I want to say, is that with AI and machine learning entering so many domains, this is the first time that we are going to have a data-driven sense for what the lay of the land is. And I think on equal parts caution, I think there's an equal parts opportunity where we know that there are things that happen in society that aren't, fair in some, statistical definition of fairness or in congruence with our values, but there is an enforcement gap between the two, which in absence of a data-driven system was really hard to bridge. And I think as AI and machine learning starts to enter these systems, we have a chance to actually make that bridge happen. Right? So I think it's an opportunity in equal parts as well.
So, Nick, you talked earlier about some of the things you're hearing from customers, particularly around explainability and transparency. Is there anything else that you hear that we should all be thinking about that customers are asking around responsible use of AI? Anything that we might be missing or is just really top of mind?
Yeah, I think when we think about AI responsibility, first of all, it is becoming a very important aspect now of thinking within companies. But what I think is coming to is actually organizations having a process for governance and, more importantly, I think quality assurance in terms of not only the technology, but the process in terms of building ML-based applications inside the organizations. And those really fall under kind of 3 key buckets of activity, and two of which are really, really important today. I think the first one, of course, is this topic of fairness and designing with principles, right from the beginning. And I think that's still an ongoing challenge. The second one is this point on transparency. And what's good about the notion of explainability is to watch the level of which the technology, and I know this isn't entirely a technology-based discussion, but the work that yourselves at Google are doing, it's going to be fascinating to see, to the point that you made earlier, in 12, 18 months, or sorry, I think it was you, Jay, that made this, that the instrumentation that will be at the disposal of companies when they're building out these applications, that they can actually have interfaces and performance monitoring and user interfaces that can actually help them with a lot of that interpretability into those applications. Now, bear in mind that from what we see is companies don't necessarily think that specific use cases aren't going to have full-scale requirements for explainability, and obviously explainability itself is a subjective topic. But what it means is certainly for as companies move to that operationalization phase, and there's a lot of dependency on the technology. Think of banking and think of healthcare and so forth. That actually there's going to be a need for some of that explainability. It's going to be challenging as well based on deep learning, and I know we're going to see more. I know there's a lot of research coming in terms of building more transparency into the way in which deep learning models operate, and I think that's going to be fascinating to see as well. And then the last tier is this whole area around security, and I think this is something that we're going to see down the road. You mentioned the point on adversarial AI. How do you protect pipelines? How do you protect models? Of course, the infrastructure underneath. So, for me, what companies need to now start to think about is embedding some of these areas of governance that are all kind of coming together now. Responsibility, explainability, governance are all kind of coming together into one kind of topic area, not in isolation, and embedding that into the design process, before the first line of code is written, right? I think that's proper quality assurance that companies need to start to think about. And one last piece on that is to think about governance not as something that we've traditionally thought, as it slows down innovation or it's a process that's mundane. Think about it, because these systems are so iterative and it's an ongoing process, it's actually the opportunity to fine-tune performance and execution. And it's part of this whole AI assurance and quality that I think is becoming more and more important as well.
Definitely true. Apparently, I missed the blue and black memo. I'm just realizing. So sorry, I didn't. Anyways, so one of the things that I wanted to ask Jay about is that a common response that at least I get when people start to explore issues, particularly around unfair bias, is, well, actually we've solved that for ourselves. This is not Google speaking. Instead we just don't measure things like race or gender or any of the sensitive subcharacteristics. And so then problem solved, we're good. How would you respond to that as an approach?
I think that's a very risky proposition to take. Right? I mean,
I'm glad to hear you say that.
even in absence of AI and machine learning, there are plenty of societal examples globally on kind of not measuring these characteristics, not leading to fair outcomes in a grand scheme of things. And that's because with any system, whether it's run by human decision making or data-driven kind of assisted decision making, there are always surrogate features, correlated things that will effectively start to correlate with things that you are not measuring, right? And could then become factors through which bias starts to creep into the system. Again, as I was saying earlier, I think the opportunity here is that if we do measure these things, we now have an opportunity to actually be rigorous against these characteristics in terms of truly measuring how biased these systems are and having mathematical ways of controlling that bias, eliminating it, as the goal of the system. And this doesn't have to happen in the overall notion of, sometimes when I hear this debate, it ends up as, are we implicitly going to a quota system, right? Is that what fairness is about? And actually it's not. The kinds of fairness control that these algorithms will gradually start to deliver, we're already seeing the first wave of those, is, for example, ensuring that the behavior of a machine learning model, that its quality is sustained across these characteristics. So not enforcing a precise quota or distribution on the outcomes, but enforcing a quality bar that stays consistent and is uncorrelated with these sensitive characteristics. That starts to say that kind of every data point, every decision, whatever be the context, is treated with the equal amount of kind of accuracy in the system, right? Which is a very different control than trying to enforce quota level policies, right? So I think as this field evolves, more and more of these granular controls will start to show up. And I think this is where there are opportunities, where if we have a conversation on responsible AI ethics and the algorithms going hand in hand, I think we have a new road to pave that can actually be really beneficial for society.
And so sort of extending from that, if you had to name one thing in fairness research or any of the ML fairness work that you've seen that you're most excited about, what would that one thing be that's coming down the pike?
Let me maybe name two.
Okay.
One that is kind of already here in terms of the pipeline, people who are building these systems could use it today, and one that's kind of coming more from the research phase. I really like the research that deals with post hoc calibration of machine learning models with regards to fairness outcomes. So this is where, imagine you're building some machine learning model for prediction, and you want to ensure that its predictiveness, the predictive accuracy and calibration isn't correlated to some sensitive characteristics you're measuring. There are several algorithms out there now, fairly stable, where you can take a pre-trained model and a bunch of data with these characteristics labeled and recalibrate that model so that it performs fairly and fairness as measured by the definition I gave earlier across this. So this means that even if the way in which you went about building the model had some biases creep in, like to the extent your population is well represented, you can undo those biases through a calibration process later on, right? Which means that it's a lightweight way of anyone building these ML systems to get on this exercise, right, as a first step, and then move up from there. So that's on the ready side. What I'm really excited about on the research side is some early work at the intersection of fairness and semi-supervised learning, where typically the hardest part about building these systems is getting data labeled across these sensitive characteristics. And the amount of that data typically is what holds us back in how good a system we could build. There is early work that shows that a combination of little bit of labeling and massive amounts of unlabeled data, we can start to get at outcomes that are very similar to having large amounts of data labeled. Right? And as those algorithms get more mature, I think we are going to see the next wave of fairness-based work show up.
So just to wrap up here, so David, you spoke about HSBC writing its own AI principles, and I'd love to hear from you. What would you say to organizations? Presumably, there's organizations in this room who are embarking on this process for themselves. Lessons learned, things that you would suggest not doing more of. any of those things. And Nick, I'd love for you to chime in on this as well from your experience.
Okay, thank you. So I think the first thing we've already said, don't write the decision tree. That does not exist.
Don't do
It
that.
will not exist. I think the best advice I can give is probably embrace respect and humility. And what I mean by that is that this is a multidisciplinary exercise. So to come up with our principles, we engage people from the technology team, from the legal team, from the communications team, from the people who thought about customer outcomes, from our risk team, from our compliance guys, because at the end of the day, the regulations we comply with are really there to protect customers and protect the integrity of the financial system we operate. So we try to treat this as a multidisciplinary exercise, not just a technology exercise, not just a business exercise, not just a legal exercise or compliance exercise. And we all try to turn up to develop the principles with respect for the other people's expertise and self-respect for our own expertise, because we're all turning up as experts, but also humility in the face of the other expertise that people had to show. So I think that's the right way to approach it. And then I think the other thought is anything you come up with is a start point, not an end point. And you need, as you design your iteration of that and your application of that, you need to build in the continuous recalibration of the principles, because as I said earlier, humans are slow to develop the ethical instincts they need to respond to new technology. This is a conscious exercise to try and accelerate, but we won't always get it right.
I come back to what you highlighted at the beginning, and for me, and what I'm seeing is that companies now are paying much more attention to build a trust into systems. And when we see when we survey companies, and we actually when we survey employees, independent of senior IT leaders, the biggest barrier that employees say, this is from an enterprise point of view, not necessarily a consumer adoption point of view, but from a business enterprise point of view, the biggest barrier they have with AI in the workplace and the enterprise is trust. I mean, they just do not fundamentally understand or have an understanding of the where their privacy comes into play, or with the accuracy of these systems, how is it going to improve their life, etc. So getting adoption is a really important one, and trust is a key part of that. So I think part of it is to start to consider these processes and this topic, right in the design phase. The challenge that companies could have had without doing this is that they have to approach it afterwards, and I think that could be. Those problems will get exacerbated because this technology moves so fast if you don't do it in the design phase. So that would be my main recommendation.
We are over time. Thank you very much for joining us today. Really appreciate it. Thank you so much.
Thank you.
Yeah.
Thank you. Makes sense.
All right, good afternoon, everyone, and welcome to Google Cloud Next. How are we doing today? Good, very enthusiastic, I see. Well, thanks for coming out. Next is one of my favorite times of the year, and so I'm glad we got to come out and share it with all of y'all. My name is Shane Glass. I am the program manager for Google Cloud's Public Dataset program. With me, I have three really awesome co-speakers that will be coming up on stage here in a little bit to kind of tell you some of their stories. Before we begin, I just want to kind of roll through what we're talking about today. So the first thing will be the current status of the Cloud Public Datasets program. We'll talk about how public datasets can support your GIS analysis, so your geospatial analysis, and how they can help bring additional value to the data you already have in BigQuery. Of course, as I mentioned earlier, we have demos from each of our three co-speakers who will be kind of detailing how public datasets supports them and how they're working with public datasets to do their geospatial analysis. And then we'll talk about next steps, kind of some actionable items that and go out and follow up on. So before we get started, if you have any questions on the content today, we invite you to use our Dory Q&A. For those of you who don't know, Dory Q&A is an app that we use internally at Google, and it helps us manage Q&A at scale because it gives everyone a chance to participate and ask questions, despite the fact that we only have 2 microphones for questions. You can try us today. Go into the Next app, click on this session. That's DA208, and you'll be able to click the Dory Q&A link from there. In the app, you can submit questions. You can upvote or downvote stuff you like. We have a gracious moderator who it may or may not be my manager, and I may or may not compliment profusely throughout the Q&A, who will be helping us kind of moderate that process. So let's kind of start with an overview and an update of the program. So here's our mission statement for the program. It's to maximize the accessibility and usability of high-value, high-demand data sets through Google Cloud Platform. Now, I get the question a lot. Why does Google do this? Why host these data sets? It's a really complicated answer. The good scientific answer is, well, it depends. But despite the details and the specifics, these all kind of fit really nicely into 3 answers at a pretty general level, right? And the first answer is that this is a really natural extension of Google's core mission, which is to make the world's information universally accessible and usable. You see these 2 words in bold up here. These are these are taken directly from that mission, so they likely seem a little familiar. And this work helps us make the most critical public data sets in the world easily discoverable, easy to understand, and easy to use. And it's a pretty fundamental core of who we are as a company. So that's answer number 1. We're following Google's mission statement. Answer number 2 is this. The current paradigm for discovering and using data sets, public data sets, can be really arduous. I'm assuming that everyone in the room remembers the scientific method, or at least everyone remembers that at some point they learned about the scientific method once upon a time. Whichever it is, don't worry, I won't tell your middle school science teachers. Your secret's safe with me. But this is what I call the data science method. And it's a really broad, kind of generalized level that describes the paradigm for analyzing public data. You can see the steps listed there. If you need a break, like need a breather or a cup of coffee after reading these, I get it. It's a really, at times, unnecessarily painful process. And it involves a lot of things that aren't analyzing data, that aren't communicating. In 2016, is that we looked at this process and realized that it was unnecessarily complicated and painful. We realized that a large number of our users were doing the exact same work. They're accessing the exact same public data sets. They're uploading the exact same public data sets. They're doing the exact same cleaning, even though they're doing different work. And we realized, hey, we could make this process a little easier by taking on a significant chunk of it. Well, what if someone did this stuff? What if we did this stuff? We're all familiar with the oft-cited paradigm that a data scientist or an analyst spends about 80% of their time cleaning and preparing their data, and about 20% of the time actually analyzing it. But what if we could change that? What if we could flip that? What if we could get people closer to spending 80% of their time analyzing and visualizing and learning from their data, and only 20% of the time kind of preparing and cleaning data? And we would do it by doing these things. And that allows you to focus on these things. And these are the things that you do. That's what you should be spending your time on. And so that's the second reason we do this, is that it helps simplify workflows and life for our users. The third answer to this question of why we do this is that our users are fundamentally telling us that this is important. This recent Gartner report from December of last year says that by 2022, 50% of cloud buying decisions will be based on the data assets provided by cloud service providers rather than on product capabilities. That's incredible. I mean, that is a massive shift in the way we understand how people choose their cloud today. In this same report, Gartner specifically identifies this program as an example of how cloud service providers are building libraries and repositories of public data sets to make it easier to integrate these data sets into cloud application. To me, that's a really clear sign of success. And so we're continuing that effort today. We have more than 130 public ML-ready data sets available, both in BigQuery and in Google Cloud Storage. And we hear from public data providers that they're really interested in collaborating with us. I mentioned earlier that this kind of feedback we get from our users is a sign of success for us. But another sign for me is that the providers of these really valuable data assets are interested in working with us and see us as a valuable opportunity to amplify their availability of valuable public data. As they would say in the 1984 hit movie, this is Spinal Tap, we're helping turn their offerings up to 11. I know it's a stretch to call Spinal Tap a hit movie, but it's a hit in my heart. So we believe that we can work with our providers and be excited for us to work together to help them advance their goals and their efforts. And the fact that they see us as that kind of collaborative partner that they can work with, I think is a really great sign for us as well. But I think that the most important sign of success is our usage metrics. And these are kind of very high-level, aggregated measurements of how much data and how often it's being used. To me, that is the fundamental clear signal that we're doing what we set out to do, that we're making lives easier for our users. And I gotta admit, we're pretty encouraged. There are 780 petabytes of volumes of data that have been scanned since 2016 from BigQuery public data sets. And these are a representation that our users are leveraging public data sets to make their workflows easier, to get to the fun part of data science, the analysis. The number of data sets with more than 1 petabyte scanned per month have quadrupled since last year, which is July. Now, to give you some context, because I know 774 petabytes is this outrageously large number, it is roughly equivalent to the number of movies it would take to stock 4,500 Blockbuster stores. And side benefit, you don't have to rewind public data sets as a courtesy to the next user. 4,500 stores would have been about half of Blockbuster's nationwide reach during their peak. This is also equivalent to 541 billion floppy disks. And I recognize that floppy disks might not be the most effective or efficient medium for storing data today. As someone who has lost multiple papers that were stored on floppy disks, I understand. But that means that it's roughly 267 billion copies of the classic Oregon Trail game, which was printed on 2 3.5 by 3.5 inch floppy disks in 1982. It's also enough to fill the nearby Oracle Park, where the Giants play, nearly 300,000 times. The long and short of this is that that's a lot of data that people are using from the public data sets. There were more than 6,000 queries a day last month alone. And that means that just in March of 2019, our users ran nearly 2 million queries that use public data sets. And this number has continued to grow as well. The number of queries per day has grown by 18 times since Next last year. And we're on pace for about 4x growth for the year for usage of public data sets. We're continuing to grow, and these key metrics are continuing to grow. I mentioned earlier that the number of petabytes, the number of data sets with at least a petabyte scanned has quadrupled. Data sets with more than 100 projects has tripled since Next, and data sets with more than 100 users have increased by 5 times since Next of last year. So all this is a really fun way to say that the program is really growing, and we're taking that as a sign that our users are encouraged by what we're doing. And I think one of the things we can do to continue to meet that need of our users is to support geospatial analysis and support the work that our users are doing with BigQuery's GIS capabilities. We provide more than 10 data sets right now that provide the polygons that define either political, statistical, or geographic boundaries in the US. So this is things like counties and states. This is things like the US coastline. It's things like zip codes and metropolitan statistical areas. Coming soon to a public data sets program near you, census tracts as well. And it enables you to easily join public data sets with other data sets for massive queries in minimal time. Things like NOAA's historical weather and storm data, MaxMind's GeoLight 2 IP geolocation database, 311 bike share and taxi data from cities across the globe, and potential solar energy that's available by zip code. Or using your private data, as we'll see here in a few minutes, you can use public data sets and join public data sets to more quickly build dashboards and have a faster reporting environment for you to share the key insights. To support things like retail use cases and the impact of weather on sales. Things like how to better understand your target demographics. Things like conducting a competitive analysis using the SEC's quarterly financial reports, training machine learning models, and on and on. And the final one is being able to quickly and easily create visualizations that can help you communicate the impact of your story and understand what's happening here. This image on the far right is a map of the state of Ohio, and it shows lightning strikes across the state of Ohio for 2018 by day. And you can see that the dark green at the bottom, which represents kind of a higher number of lightning strikes, really stands out. And so this really helps you communicate that message really quickly and really easily. Now, I could stand here all day and talk about the Cloud Public Datasets program. Quite frankly, last year I did. But that's because I'm truly passionate about it. This is really what I love. But I think you folks would much rather hear it from the people who can best highlight how to use these data sets and how they can work with things like BigQuery's geospatial analysis capabilities or the ML-ready public data sets we have. And so with that, I'd like to introduce developer advocate extraordinaire here at Google, Felipe Hoffa. It's always a pleasure to work with Felipe, and I'm really excited for him to show you what he has.
Thank you, Shane. And thank you for all the data. Now give me a clicker. Give me a clicker, please. Shane. Clicker. Thank you very much. Thank you. I'm Felipe Hoffa, Google Cloud Developer Advocate. I love having a clicker to show the slides that I have prepared. I also love data. I love analyzing data. And for this public data talk, I want to use some of my private data. So since 2012, I've been recording everywhere I've been, almost minute by minute, and I have that data in BigQuery in a private data set. So now I can analyze it. So this is a table where that shows everywhere I've been. Just I have the day, the time. I deleted the time from this version of the table, but I have it point by point, and I constructed a BigQuery GIS point for each of these places. And now I can map, I can visualize all of these points. If you were to analyze my life, the place I've been the most times in is my house. The second place I've been the most in is the office. Any guess what's the third place I've spent the most time in? The bar is one. That's like the fifth. The third is the airport, and the SFO airport. And the rest of the time, this is everywhere I've been since 2012. Yes, I've been traveling a lot. But these are only points in the map. I would love to enrich them, give them more meaning, know exactly where I've been, what cities, what countries, what continents. And now with the public, I can find public data sets that have some of that data. For example, GeoLight 2, MaxMind publishes a database that allows you to geolocate IP addresses. And we have a copy of this database in BigQuery, thanks to Shane. And I can not only find IP addresses here, I can find a list of cities. And I can find also what are the most important cities just by looking at how many IP addresses each city has mapped into it. And I took this table, I reduced it to only the cities I'm interested in, and now I can do a join between my points and wherever the cities are located, and then for each point I can find the closest city. Now, how do you do that? You could ask that. In fact, I asked the question, and then I replied to my own question, and that's yes, I didn't give enough time to anyone else to answer it. Sorry, Michael. Michael is one of our top Stack Overflow answerers, he's from the community. And he's here, so I'm super excited to have him here. But this is my query, and it works really, really fast. Once you have your points encoded as GIS points, BigQuery is able to quickly scan and index, go through this data. So with this query, I can just find everywhere I've been, and I can visualize it. This is the results of the query. Then I can, for example, move this data into Data Studio, and this is an analysis of how much time I've spent outside of San Francisco, in North America, Europe, Asia, South America. You can find every country. And I love doing this. Now, what else? In what other ways can I enrich this data? I could also find what's the weather been like for me. So have I been to hot places, cold places? Well, thanks to NOAA, we also have the daily weather in BigQuery. And instead of finding the closest city, I can find the closest weather station. Basically, I can run the same job. Now with the GSO OD table, I also transform this table to make the latitude and longitude into a native BigQuery type. I run the same query. And what you can see here is for each of my days, what was the temperature, and in each different color, in which country I was at that time. So you can see, for example, when the line breaks is, for example, I was in summer here, and I went to Chile in winter, so there is a big jump. Or you can see all of my Christmas, if I spent it either in 2014, I was in Egypt, that was pretty hot. Then in 2015, I went back home in Chile, that was hot too, summer in Christmas, then a cold Christmas in San Francisco, and then I had a very cold Christmas in Japan. And I can find and map all of this data very, very easily just with BigQuery and enrich my data with the public datasets. Now, I have a lot of friends that live in Seattle, and they tell me to not move there because it's always raining. That's not my experience, and I just want to prove it. Basically, I can find out every time I've been in the Washington state, and I can measure how much rain I have seen. Here you can see that I've seen cold days, I've seen hot days, but I have never seen 1 millimeter of rain. And I have the pictures to prove it. So, but my message is, take your own data, take your business data, take public data, and just enrich it, use our public data sets and all of our geo capabilities. And to see what people are doing at a larger scale, let me welcome back Shane.
Thank you. Can you give this to Claire? Can you give the mic to Claire? Yeah, thanks, Felipe. I'm actually a little flabbergasted that home was the top place you spent your time. I would have guessed San Francisco Airport, so at least I'm in the top 3. Felipe actually kicked around a few different options for demonstrations, and I'm willing to bet you'll see some of the alternatives in a future webinar. But we chose this demo because of how well it ties into our next story, where PushPay is using public data sets to better understand the lives of their customers. Which helps them determine how to focus their marketing efforts. And as someone married to a marketer, I can very, very sincerely appreciate the efforts to make any marketer's life easier. Now I'd like to welcome to the stage PushPay's Director of Marketing, Claire Haig, to talk about how public data sets has helped them better subset for their potential user base.
Thank you, Shane. All right, Great. So I am going to talk about a little bit different topic on how this is helping us make some pretty sticky business decisions using the Public Data Sets program. So first of all, I feel like I need to give you a little bit of context into who and what PushPay is. So we build mobile apps to connect community members outside of the traditional sort of Sunday, Monday, Tuesday type meetings that happen within churches and not-for-profits. We want to make sure, and just as importantly, that they also have a way to get payments and donations in a seamless pattern as well through this mobile application and as well as a web platform. So New Zealand is our founding place, but most of our customers are actually here in the States. So this is the perfect opportunity to kind of talk about how the situation looks for us here using public data sets in this country. So setting the stage, we have about 7,500 customers. We are about $25 million per quarter in revenue, and our annualized processing volume just reached about $5 billion. So when you look at the breakout of our revenue, we get about 30% of it from a SaaS fee, like a typical company, and then the other 70% actually comes from small transactional fees on that processing side with every gift that gets transacted. So when I arrived at PushPay, coming up for about a year ago now, it kind of struck me on how we segment our customers out. If you start to dive into the data, the gravity of this sort of breakout starts to mean something to you. So traditionally, it was pretty incongruent with the way that we actually did our sales process. So it's looking at our customers sized by their weekly attendance. So in a church, it's a pretty hard number to try and get, one thing that our platform helps them do. So most of our customers are giving us a self-regulated, generalized ballpark of a number. And then when you look at where the majority of our revenue actually comes from is the processing side, and most of them either have a very indiscriminate number of what they think their revenue actually is. Churches don't typically think in revenue numbers. It's not where they place their time and thought. And so when we were founded, and we're a fairly young company at the end of the day, this looked like a really simple solution to a very simple problem. Our customers give us a self-reported number, whatever number that is. We have a baseline of what we're going to charge them for that monthly SaaS fee, and then processing fees are all standard. So as a product marketer, I wanted to reassess our pricing model so that we could maybe do something a little bit more like a monthly active user model, because we are a mobile application. And in doing so, I realized quite quickly that we didn't have accurate data in any way, shape, or form, either on the number of members that were in the churches or the processing volume that was going through individually. So fortunately for me, I moved to PushPay from a company called Socrata, which was the pioneer in open data portals for the government, so where a lot of the public data sets actually come from through the Socrata API. So with this data, knowing that there was public data out there somewhere for me, I took to BigQuery and was able to find the IRS 990, which in layman's terms is basically all of the not-for-profit data revenue from the IRS put into BigQuery here. And then this was great. So now I knew the data existed. I had really easy access for it. So now I can actually start to test my hypothesis a little. So knowing that churches come in all shapes, sizes, colors, and flavors, this must mean, in my head, I'm thinking there must be differences in how churches give, how the members of those churches give. And so if 70% of our annualized revenue comes from these transactions processed through the platform, then budget is a really big factor when determining the lifetime value, segmentation, and ultimately the cost to the customer. So if this were, so this basically was, in my hypothesis was, how are we charging our customers? We're probably overcharging some of them, undercharging others. And I wanted to make sure that we had a more stationed way to do that. And so through some great help from Shane. You know, I'm smart in the ways that I'm smart, but I'm not a data scientist, but I didn't want to bother our data scientist team to go and make a bunch of, you know, queries and assumptions based on my, you know, tiny little thought that maybe this was the way that we could reprocess and resegment our market. And so while BigQuery gave me a really good opportunity to segment out the data and get the data to a point where I could extract it, I wanted to see it in a little more visual way. So what I loved about this is I could actually just take it into something that spoke my language as a marketer a little bit more and pull it into Data Studio. So the initial insights here, while it's exactly what I thought I was going to see, I was still a little bit shocked. So what you're looking at is that the bottom axis is the attendance of the entity, and then the top is the revenue. So there are actually a bunch of churches that have really small congregations, but very large donations, some of that due to maybe location because of high propensity towards giving or higher median income levels. So churches have a lot of other differences in what they do as well. We have Protestants, Catholics, Episcopalians. Each of them have a different view of stewardship and what it means to donate to your church versus what it means to give to maybe an associated school or another not-for-profit. So for example, we have one Protestant church in Arkansas that has 8,000 members, but barely breaks the $2 million donations per year mark. And we have an Episcopalian church in Seattle, near another very big data school, where they have about 800 members, but they're actually breaking over the 10 million mark. Part of that is due to median income levels, and part of that is just due to the differences in how fundamentally that denomination thinks about donations. So for me, the funny thing is you're at a geospatial talk, but the icing on the cake was actually the geographical side. So there were obvious geographical differences as well. This is all of the data based on location. One thing that you will note, there's a lot of dead space in here, and that's what we're going to be able to fill in with some of our data, because not every church is required to, in every state, is required to actually file for their 990. And so with that missing data, we'll be able to fill in again from sort of our set of data. But what this shows is where we have our sales territories might also be something that we need to consider changing, making sure that each and every one of our sales team members has the right capacity underneath them. And then, so for me right now, the next step is I'm going to add more public data, median income information, for instance, and then I'm going to actually look at setting up our team so they have equal opportunities depending on where they're at. And so net, the real work actually kind of now begins. I'm at the front stages of this, but I get to go back literally on Thursday. I have a meeting with our board of directors to talk about where we take this to the next level at the company. So I'll be sitting down with that team. I'm armed with action evaluate when making these big, broad, company-wide decisions before I go to my data science team and derail the work that they're already doing. I've actually kind of helped with part of that 80% through the use of BigQuery, and it was a pretty easy process for me. And so the thing that we're going to be able to do is actually resegment our prospect base so that our customers are segmented the right way, more on a per capita of budget dollar, rather than just a stained number of how many people come to the church on a weekly basis. We're going to be refreshing our pricing model through our platform. We're now able to look at the number of members that go through and actually use the platform, so we can actually have a more reasoned approach to how we're doing that SaaS fee. And then on top of that, we're going to be able to look at how we're structuring out our sales team so that from a territory perspective, I don't have one person who's unfortunately over in one of those dead zones that doesn't have a lot of high donating areas, so that from a processing side, they're getting the same amount of volume as we change the way that we do our quotas as well. And again, this is something that we're able to do incredibly easily just through this program. And then the ability for me to make these visualizations was 100% seamless. You just click a little button, and it was the easiest thing I've done all week. And so for the next step on my side, as I go back, I'm going to be looking for more data that exists in the program that I can pull in, and then take that back and have these conversations. So hopefully next year, if I get asked back to talk again, I'll be able to say, hey, this is what we actually were able to accomplish, and the more, so sort of the more data sets that we were able to pull in, I believe the more impact we're actually going to be able to have for our company.
Yeah, thanks, Claire. You touched on one thing that, the IRS 990 data set in particular, the way it's coded is kind of very specific, right? And you have to be able to go into the documentation and understand what these codes mean and what they are. And I think that's kind of one place where we work really hard to support data providers, is not just helping their data scale, but helping their expertise scale, and making sure that we do a really good job of explaining what the data are, what they mean, and what some potential limitations are as well. And we'll dig into that a little bit later. Claire and I were actually talking just before the session that she was telling me a story of some churches that were impacted by the campfire last year, and how PushPay and their kind of subscription to PushPay had helped kind of support neighboring churches that were impacted. And I think it's just such a natural connection to our next speaker, Keon, that tells such a really great story of how we can support folks that are impacted by natural disasters. I was actually here in San Francisco last year, the day that the campfire started, about 200 miles from here. And I distinctly remember how quickly the smoke blew into San Francisco, and just how thick the smoke was here, 200 miles away from the center of the fire. So I'm really excited to have Mayday here. Their work is helping support first responders as they respond to natural disasters around the country. And I'd now like to welcome to their founder and CEO, Keon, to the stage.
Hi, everyone. I'm Keon Rishai, founder and CEO of Mayday.ai. We are an artificial intelligence-enabled disaster information services platform providing real-time and near real-time services to first responders as well as residential and commercial subscribers. So I just want to spend some time dealing with, giving you some statistics before I get into some of our services. In the past 20 years, globally, there's been close to $1 trillion in damages from disasters. The United States takes the lead, going through about $1.5 billion in damages, followed by China and Japan. The most devastating, as you've probably experienced, are storms, followed by wildfires and flooding. In fact, over the past few years, the average damage caused by storms are close to $100 billion a year. Wildfires are close to $30 billion a year. And floods, half of Iowa is flooded as we speak, close to $20 billion per year. Just another depiction to show you how serious and severe these events are becoming in the United States alone. So this is a chart that's put together by NOAA. As you can see, in the 80s, so 20 years ago, you'd be dealing with a few billion-dollar related disasters, causing about 60 or 50 billion in damages. Look at the exponential growth all the way to 2017. You're looking at dozens, maybe even more, causing some 360 billion a year. So 2017 was actually a record year, 360 billion, not just for the United States, but globally, followed by 2018, Florence, Carr Fire, the red tide in Florida, and 2019 is already the wettest year on record. So what used to be kind of seasonal and predictable is shifting to become a lot more unpredictable and random. So For wildfires, for example, you could almost set your watch to it. When it came May, you could see some fires starting to appear, and then by October, you could say you can start your Christmas vacation if you're a firefighter. Thomas Fire was in, Carr Fire, was in November. The Thomas Fire was in December. So you can see how anytime, almost 9-10 months of the year, we could have wildfires here. So almost 70% of the country is exposed to these events. As you've experienced, they're becoming more severe. They're expanding larger and larger wildland and urban areas, creating a need for us to think about how we manage disasters differently. So obviously, being reactive to these means billions of dollars more. Being proactive means possibly getting to these sooner and look at ways and means that we could reduce these damages substantially. So yes, these events are extremely challenging, but there are some systemic challenges with disaster management that make this even more challenging, if you believe. So amplified by so many factors. And this isn't just unique to the United States. This is a global problem. So from a tech perspective, you're dealing with platforms that are highly decentralized. They don't communicate with each other. There are limits from an infrastructure perspective. So if there's any damage done to an infrastructure during a disaster, you can't access critical information. From a process perspective, you can't really have a standard process for a lot of these events, different jurisdictions, different territories. And then you deal with the politics of information sharing. The simple fact of who gets credit, who gets blamed, can mean how quickly an information goes from a national level organization down to a city level or vice versa. Resources, well, you can never really train folks enough to handle some of these events. And from a general public perspective, folks are rarely informed in a timely fashion. So the notion of getting real-time information does not exist today for a lot of these disasters. And of course, the first responders are always trained. So about a year ago, I founded this company to ensure that we can try at least, handle some of these challenges, but at the same time, democratize, pertinent disaster information when it's needed most. What I'm proud to tell you today is that we've built a platform with Mayday that allows for centralized and a cloud-based, or essentially microservices and cloud-based platform that makes the ease of integration and users this platform fairly easy. It allows for event-centric communications. So you're probably used to getting Amber Alerts. This is more event-centric to first responders and folks who are affected, whether it's an individual or a group, based on a selected area or a radius. And it's highly, highly affordable. So in sum, this is what our ecosystem kind of looks like. We cater to residential, commercial, and governmental customers, catering to iOS, Android, and Microsoft, various devices, as you probably know, using various data sources. So the Google Cloud program and the Big Data program is a big part of our training and learning. We've used this in many scenarios, and it continues to be a big part of that. We use geostationary and orbital satellites, as well as drones, sensors, and social media sentiment analysis to create real-time and real-time information services covering the disasters that are highlighted below. So, Campfire, this is just before the sunrise that we detected this event, almost a couple of minutes after it occurred. So this essentially makes us one of the fastest platforms in the world. The yellow boxes show potential hotspots. The red boxes are confirmed events. And the green boxes are false positive or events that have ended. So why does it matter to be notified a minute earlier? Well, the campfire was burning 100 or so houses a minute. What if you had 30 minutes more to prepare? How much of a difference would that make to your life? So it's key to have information when it's needed most so you can handle an event like this or many more events like this. And as Shane was alluding to earlier, you can kind of see the smoke pattern after this event. So that's the pollution or the level of carcinogens that we deal with after a wildfire. We're actually introducing a product that deals with pollution, air pollution, real-time particles with AI that we'll be introducing. But essentially, this is a quick demo of what we've been able to successfully conduct with the Big Data program. So from a timeline perspective, we're very excited to be launching this platform in Southern California. We'll be working with MetroNet, launching with 8 cities out of OC, officially in May, and we'll be expanding this to the rest of California in June. Wildfire awareness is a big part of our campaign. We want to continue to educate and re-educate folks through universities and educational institutes. The app is free for students, and it's $1.99 per family, or 99 cents per person per year. So highly affordable. We'll be launching the fire products to begin with, including drone services for reconnaissance and for delivery. In Q3, we'll be introducing a whole host of new products, including IP911, active shooter and terrorist attacks. Q4 will be larger expansions of our products, with some European and APAC expansions, and 2020, it's our global expansion to a whole host of platforms in Europe, as well as other disaster prevention mechanisms that we'll be using. With that being said, I want to thank the Google Cloud and the Big Data program and how crucial they've been to this campaign, and we're really excited to launch this product.
Thanks, Kian. This is a really powerful capability that y'all are working on, and we're really proud to be able to support your efforts to enhance the impact of first responders and emergency managers as they respond to these natural disasters. So we've seen 3 really powerful demonstrations of how Google Cloud public data sets can support your geospatial analysis for just about any use case. You saw a demo from Felipe to help understand how the world around you impacts your life. We heard from Claire about how public data sets can help you make more efficient, data-driven business decisions. And Kian just demonstrated how public data sets are helping Mayday support the community around them. So obviously now you're all very excited about public data sets. What can you do next? Which is a really, probably overused Google Cloud next pun. So let's start with what you can do this week. The week is young. There's still a lot going on. The first thing you can do is stop by the BigQuery booth. Either tomorrow or Thursday, I'll be at the BigQuery booth myself, and I would love to talk to you about public data sets. Any questions you have, any suggestions you have, I'd love to hear from you. The other thing you can do is check out more of the sessions that feature or talk about public data sets at Next. There's a couple on here I really want to call out in particular. One of them being the Kaggle session. That's hosted by Anthony Goldblum, the CEO of Kaggle. But he is also going to be talking about the Kaggle Public Data Sets program, a group with whom I work very closely to kind of coordinate our efforts. There's also some hands-on visitor purchases using BQML and data visualization with Google Maps and BigQuery. So those are kind of going on at any time, but there will be some people around that can help answer questions and kind of troubleshoot some challenges you might have. And if you want to learn more about Data Studio or BigQuery GIS, check out these sessions, including the planet scale geospatial in room and then one from the Dory as well.
Hi there. Hopefully this actually touches on one of the Dory ones. It's sort of a twofer. One of the big disasters that we're facing, and I'm really grateful, Kian, for your presentation, is, of course, global climate change. And we know that there were a lot of citizen scientists who did a lot of rescue efforts around EPA data sets when those were under threat a couple years ago from the current administration. So how can we, as people who are in the public sector or in social services or have interest in environmental data sets and have that domain level knowledge, how can we raise a flag and say, hey, Google, you say do no evil. Here's a great way for you to save a data set. How can we make that happen? How can we advocate for data that we think is important, that you can do a service for the community of data consumers?
Yeah, and I think this does touch on one of the questions in the Dory about community upvoting and community contributions. I think that's the big takeaway from this session for me is that we need to get something like that up off the ground fast. I have a few ideas in mind. I think I want to kind of flesh something out a little more clearly. But we'll write a blog post and we'll have it out once that's ready. And that'll be our way of kind of telling everybody. So just keep an eye on the Google Cloud blog. Shameless self-promotion. Keep an eye on my Twitter because I'll tweet it out. Keep an eye on Felipe's Twitter because he's funnier than me. But yeah, so that I think was a big takeaway for me that's something we need to get off the ground as soon as possible. Yes, it's at Felipe Hoffa, sorry. And then Will, I think we have a question from the Dory.
Yeah, I've got one here. It's, is Geolote 2 suited for identifying cities in Latin American countries like Colombia, Ecuador, Argentina, Peru, and the Dominican Republic?
The question was if Geolite can work with cities in Latin America. Yes, Geolite works with all of the cities I visited, even towns that I've been visiting around the world. So it's all supported.
Yeah, and well, there was another question in the Dory about international boundaries and whether that's something we're working towards. And the answer is yes. We started with the US boundaries because this was a little of a new process for us. And it was, the Census Bureau kind of is a really, really well-documented site to go to get these kind of things. But we are very interested in expanding out to other countries, to international countries as well. So keep an eye out for that as well.
For the BigQuery public feature tracker, you will find a place to ask for anything you would like to ask, and we will follow through.
Yeah, and I want to get something more specific to the program creator as well. So we'll work on that, and we'll make that known as soon as possible. We probably have time for one more question if there's anyone in the room. If not, we could take another one from the Dory. Okay, Will, do we have yeah, oh, I'm sorry, go ahead, sir.
Do you guys have holiday event data or weather forecasting data within public data sets?
Yeah, so the question was, do we have, I think you said holiday data and weather forecasting data?
And also events, like public events like Google Next or games?
So for events, no, but that's certainly something we could take a look at. Holidays, I think we could pretty easily kind of figure something out and figure out how to make that work. For weather forecasting, that is by far the #1 request we get, and we're working on it. We're working really hard with NOAA to do it now. The way they publish the data is in a very specific kind of proprietary file format, so we're working with them to try to figure out how to get that into BigQuery, because I think that's the right answer, is put it in the same place as the historical data in the same format. So we're working on it, and I hope to have that done soon. Thank you for asking. So we are out of time, but I really appreciate everyone coming. If you didn't get a chance to ask a question, the Dory will be open for another few weeks, so feel free to add your question in there, and we'll answer it in there as well. But thank you very much, everyone, for coming, and enjoy the rest of your week.
Hello, everyone. My name is Sergey Sokolenko. I'm a product manager in the Google Cloud. Today with me I have Christopher Crosby, one of my PM colleagues, and Ravi Upreti from Qubit. And today we're going to talk about data processing options at GCP, Hadoop, Spark, and Dataflow. So the session today will be quite simple. We're going to give you an overview of the options you have. We're going to give some recommendations on what to choose. We're going to do deep dives into Dataflow and Dataproc. And then we're going to ask Ravi to come up and tell us the story of Qubit and how they use Dataflow and Dataproc. So let's get started. Data processing in the cloud, Google Cloud, is part of a larger data analytics offering set. Starting with data ingestion, you have access to Cloud PubSub, which is our messaging solution for streaming events. If you need to move structured or unstructured data to the Google Cloud, you can use the data transfer service. And if you need to connect your IoT devices, Cloud IoT Core is the solution for that. Now, once you ingest the data, you have now options to process it. And what are the options? If you're building a streaming solution, if you prefer accessing a state-of-the-art streaming framework such as Apache Beam, then Cloud Dataflow provides a managed service that unifies batch and stream processing. If you're coming from the Hadoop and Spark world, would like to continue using these tools, have an investment in a skill set like these tools, like Spark Streaming, then Cloud Dataproc offers a managed service, and that's a great choice. We also have a service called Cloud Data Prep. It's a visual UI tool for data wrangling. It's based on Cloud Dataflow underneath. It runs Dataflow jobs when data needs to be crunched. But to you as the end user, it's exposed through a user interface. You don't have to do any coding. Now, once you ingest it and process data, you have to store it somewhere. So where do you store it? You have two options. You can store it in BigQuery, our cloud data warehousing solution, or you can store it in the Google Cloud Storage if you're building a data lake. Once you stored your data, you have access to yet more advanced analytics products. For example, you can run predictions using Cloud ML Engine, or you can visualize your data using Cloud or Google Data Studio. You can also do full-scale, full-blown TensorFlow implementations and run them in self-managed mode or with Kubeflow. Or you can do your spreadsheets using Google Sheets. Combining all of this and kind of binding this together in a end-to-end solution, we have Cloud Composer, which is a managed Airflow implementation, managed Airflow service, which allows you to put all of these pieces together in a working end-to-end workflow. Now, how do you choose these options? Specifically for data processing, there's a very simple set of rules. If you're modernizing your data warehouse, if you prefer the ELT paradigm where you extract, load, and transform, and do the transforms, the processing inside of a data warehouse, then BigQuery is the solution that you should pick because it gives you rich SQL. You can write your SQL statements, SQL scripts, solve the problem that way. If you're building a streaming solution, if you want state-of-the-art streaming, unification with batch, exposure to Apache Beam, then Cloud Dataflow is the best managed service for you. If you prefer Hadoop and Spark, if you like Spark streaming, if you have existing investments into Spark and Hadoop, then Cloud Dataproc is a great way to run open source software in the Google Cloud. Now let's do a deep dive into Dataflow, starting with Dataflow. But before I do the deep dive, let me explain the differences between Beam and Dataflow. Several years ago, Google has open sourced the Cloud Dataflow SDK, and it became a top-level Apache project. In 2018, last year, at the end of the year, the Apache Software Foundation shared a couple of stats about all of their projects. And it turns out that Apache Beam is now the top project, or was in 2018, the top project by the dev list activity. It was the top 3 project by commit activity. So there's a lot of excitement and developments happening in the Apache Beam world. Why? Well, users like the fact that it provides a simple and unified batch and streaming API. You don't have to use different tool sets for batch and streaming. You can use one set of tools, one API. And portability, that's another big selling factor for Apache Beam, or big benefit of Apache Beam. Portability across runners. For example, you can write your Apache Beam pipeline and run it in the Google Cloud on Dataflow, or you can run it on Apache Flink, either in a different cloud or on premises. In addition to the runner portability, Beam also envisions portability across languages. So imagine a pipeline that uses some I/O connectors written in Java and some data transformations written by another team in Python, and perhaps yet another set of transformations written by yet another team at your company written in Go. It's pretty powerful if you're able to combine all of these components together. Now, Cloud Dataflow uses Apache Beam as its only SDK. This is the SDK that Cloud Dataflow is offering to its customers. It's a serverless, fully managed data processing option in the Google Cloud. Together with Cloud PubSub and with Beam, Dataflow offers exactly once streaming semantics. What does it mean? It means your messages get processed only once. Dataflow takes care of error handling and data deduplication. We also optimize used resources, not just resources, but also time that is spent on processing your resources. I'm going to explain a little bit later how the optimizations are working. And lastly, Dataflow offers separation of state storage and compute. And this separation allows us to scale the different components of your pipeline, the place where the state is stored, the place where the calculations are done. We are able to scale them at different rates, which improves our auto-scaling behavior. So let me talk a little bit about the vision behind Beam. And I'll use an example of a typical transformation, summation of values based on keys. So if you want to do a group by and sum all the elements by keys, it's a very typical operation. The vision of Beam is to offer a variety of such operations, not just sums. Summation is just a simple example, but all of the APIs should be available across different languages. The languages that are supported today include Java, Python. We have an experimental Go SDK, and we also Beam supports Go. When sometimes I say we, I sometimes mean Beam, and sometimes mean Dataflow. It's because a lot of folks who are working on Beam are also coming from Google. But we have a large community of non-Googlers contributing to Beam. Actually, the majority of people working on Beam is, at this point, non-Googlers. So in addition to this language portability, the other part of the vision for Beam is the ability to run in different environments. Imagine you wrote a pipeline, and you decided to run it today in the Google Cloud on Cloud Dataflow. And next day you decide, well, I could actually use locality, and I could do some data processing close to my data. So why don't I run my pipeline close to the data in my on-premises environment using a Flink cluster? That's pretty powerful. There's a variety of different runners being developed right now. Flink and Cloud Dataflow are the closest to, are the ones I would use in production. There are other environments or other runners that are being developed today. Apache Samza is another one that is pretty close to being used in serious environments. There's work being done on the Spark runner and other runners as well. So now that we understood the vision behind Beam, let's talk about Dataflow. Lots of our customers like the fact that they don't have to understand this diagram. For them, Dataflow is a black box. It connects sources and sinks. What happens under the hood doesn't matter. For those of you who actually do want to understand what's going on, let me just explain what's happening in this black box. First of all, Dataflow takes care of resource management. What do I do? What do I mean by this? I mean creating resources, storage resources and compute resources. These are the boxes in the middle of the diagram. And scaling them up and down separately, depending on how much data I have remaining that needs to be processed, and based on the parallelization capabilities of this data. Some data is more parallelizable for processing than other data. And if we encounter a data set that is easily parallelizable, we will create lots of resources that will crunch through your data very quickly. It will actually save you money and time for processing. So the other things that Dataflow does is, I already mentioned, dividing data sets. That's the work scheduling piece and dynamic work rebalancing piece. So we always keep track of the small pieces of bits of data that we have to yet to process. We assign them to processing nodes, We tracked how fast the work is being done. If we can improve the time execution, we will create new workers and assign the data to them. This way saving you resources and execution time. We also do some mundane things like logging and monitoring. And it turns out monitoring is not that mundane. Some of the improvements that we've made over the past 3 months were actually about improving monitoring capabilities. Let's talk about what's new. Everything here was released or has been launched over the past 3 to 4 months. So you're looking at pretty fresh stuff. We are continuing investing in our streaming capabilities. We would like to be the best-in-class streaming solution. One of the things we launched recently was the exposure of 2 central metrics for streaming pipelines: system latency and data freshness. Freshness in other parts is called watermarks. So we are exposing them now in your job details page right there. It's visible to you. You don't have to go to Stackdriver to get these metrics. And in addition to seeing these statistics, you can also create alerts based on predefined thresholds. We released a streaming support in the Python SDK, and we worked with the Beam community on creating a production quality Beam on Flink runner. If you are interested in learning more about how Lyft is using the Beam on Flink runner in their environment, come join us on Thursday at 11:40. Thomas Wiese from Lyft will be co-presenting with me about Lyft's usage of the Beam runner. In addition to improvements in streaming, we also done a bunch of improvements on our service side, starting with a redefined and redesigned UI for creating jobs. We made it very simple to create single source to single sync ETL jobs. We now offer about 20 plus different ETL templates. For example, you can move data from Bigtable to GCS storage, or import data from GCS storage into BigQuery. But lots of combinations of sources and sinks you get for free when you use these templates. We developed and released a new connector for BigQuery's fast storage API. We improved our security, your security actually, our support of your security, by, for example, not requiring you to use public IPs anymore. You can use private IPs for your Dataflow workers. Very recently, we launched support for VPC service controls. This helps you preventing data exfiltration threats. And lastly, our batch customers like the fact that they can join and group hundreds of terabytes of data using the Dataflow Shuffle. Let me show you a quick demo of how easy it is to create a new streaming job that dumps all of the data from a PubSub topic into GCS storage, in effect creating backups of streams, and then creating alerting for these streaming pipelines based on predefined conditions. Demo, please. All right, so I'm currently in the PubSub browser. I have a PubSub topic called transactions. And this topic has a never-ending stream of sales transactions, things like who purchased the good itself, the sale amount, the place of sale, the time of sale. So what I want to do, I want to create backups of data in this topic. And I can do it very easily now by going to several of the contextual menu options. Not only can I import, I can actually export as well. I can export into BigQuery, or I can export into cloud storage. I'm going to choose the other option, cloud storage. And within a few seconds, a new screen will pop up that will allow me to complete my flow. All of the relevant values are pre-populated. For example, the Dataflow template that implements this flow is pre-populated. There are many, many more. Just look at this list. I could have exported and backed up a Cloud Spanner database into storage, or I could have imported or exported data from Bigtable into storage. But I'll stick with my predefined template, my PubSub to text files, and just finish up typing in the name of the destination. This is the bucket where all of my PubSub transactional data will be stored. I'm going to give every file a prefix so that I don't lose it in the output bucket. And I'm also going to type the name of the temporary folder. And I will actually not forget this time to change the name of my job because I've done a couple of pre-demo prep and created several of the same job names. All right, within a second or two, Dataflow will populate the execution graph of this pipeline. It has 3 steps. The first step is reading from PubSub. Then this template will window all of my data elements in the stream into 5-minute chunks. And each of these chunks will be then stored in cloud storage. It takes a couple of minutes to populate enough data to enable my latency graphs. Let me save the time and just pop into another job that I launched before the demo. Here's how it looks after a couple of minutes. I now see that my pipeline has about a couple of seconds, 3, 4, 5 seconds of latency. Latency measures the time between when an event enters the pipeline and exits the pipeline. And I have appropriate statistics for freshness as well. So what if I want to define an alert for this pipeline where I want to get notified if the latency of my system exceeds 20 seconds? This is very easily done now by clicking on this Create Alert link, where I will be rerouted to Stackdriver Monitoring with a bunch of values already pre-populated. I'm going to keep most of the filters the same. Yes, I want to monitor Dataflow jobs, and the metric that I want to monitor is system lag, and this filter also works for me. Job name equals my job name. What I do want to change is the threshold. So 20 seconds. Once I exceed 20 seconds, the values are in milliseconds, so I actually have to type in 20,000. So once the value reaches this value, I'm going to get an alert. And let me just save this alert. And voila, I've got an alert. I'm going to get a SMS or an email whenever my pipeline gets slow. Back to slides, please. So what else is new? There are 2 other areas where we've done good improvements, and I actually wanted to quickly explain what all of these new products mean: TensorFlow, Kubeflow pipeline, etc. We are continuing investing in our machine learning and AI support. TensorFlow Extended is open source machine learning platform for production use, kind of on a serious scale. Kubeflow is a Kubernetes-based machine learning platform. It works with TensorFlow, but it also supports other frameworks. And Kubeflow Pipelines is the technology part of Kubeflow that creates infrastructure for data processing for Kubeflow. So the things that we improved over the past 2 to 3 months is we created an integration point with Kubeflow Pipelines. So you can now do feature pre-processing using Kubeflow pipelines that will spin up a job in Dataflow. Dataflow and Beam are powering TensorFlow Extended. All of the major data processing tasks of TensorFlow Extended are running on Apache Beam, and by extension, they can run either in the Google Cloud on Dataflow, or they can run on Flink. And lastly, we keep investing in our Python support as well. For example, we recently released a Bigtable Python connector. We launched support for Python 3, and I already mentioned our streaming capabilities that we released in beta. And with this, I would like to invite Chris to talk more about Hadoop and Spark in the Google Cloud.
Thanks. Hey, everybody. I'm Christopher Crosby, and I am a product manager on our open data and analytics team. And so I'm here to talk about how Spark and Hadoop, combined with Cloud Dataproc, can help you do processing on cloud-scale data sets. So our goal with Cloud Dataproc is to let you take the open source tools, algorithms, and programming languages that you're using today, but apply them to cloud-scale data sets, while at the same time helping you integrate with the rest of the Google Cloud ecosystem. So I think we've established this already, but Cloud Dataproc is Google Cloud Platform's fully managed Apache Spark and Apache Hadoop service. And while I'm saying Hadoop and Spark, it's really an open source, an engine for running open source software in that ecosystem. We offer customizable machine types, which means that if you have a set of machine learning jobs, those could live on one cluster that's very compute intensive, while at the same time you could have a set of BI or ad hoc analysis applications that live on a memory heavy cluster. The two never have to contend for resources, but they could both be pointing at reading from and writing the same data sets in Google Cloud Storage. And we offer you a lot of tools and features specifically designed for managing those type of architectures and ephemeral Hadoop and Spark clusters just in general. We also give you tight integration with the rest of Google Cloud Platform. So this is not just us giving you yet another cluster that you have to manage. We are going to let you run your existing open source software, but still modernize your stack. Dataproc also gives you a lot of flexibility and a lot of different knobs you can turn. Now, we do our best to create some sane defaults for those knobs, so it's really easy to just get going if you don't care. But because we do expose those knobs, we find that customers use Dataproc in a couple different ways. The first way is what we refer to as job-scoped clusters. And this is really efficient for batch and ETL type processing. In this mode, essentially what you can do is have a single command that sends a graph of jobs to Cloud Dataproc. We will spin up a right-sized cluster, run those jobs, make sure that your cluster is torn down, and then save all that information into Stackdriver to make sure that you have a full record of everything that happened while that cluster existed. And because Cloud Dataproc can usually give you a fully loaded Hadoop cluster in around 90 seconds, this is a really effective model for starting to think about jobs and clusters as a single entity. And so customers have a lot of success with this model. And we have a lot of features like our Jobs API or workflow templates or clustered scheduled deletion that helps Dataproc customers with this model. Now, we also have customers that tell us they have scenarios for semi-long running Cloud Dataproc clusters. Examples of this might include things like a shared cluster for interactive or ad hoc analysis, often with web notebooks like Jupyter or Zeppelin, or BI applications built on tools like Druid. And we have plenty of features that help with this as well in Cloud Dataproc, things like our high availability mode or our autoscaler. And if you want to learn more, I actually did an article a couple months back on my top 10 tips for running long-standing Dataproc clusters. There's a webinar associated with that. So there's a lot of materials out there on the web already if you want to learn more about how to go and use Cloud Dataproc for long-standing clusters. But regardless of which model that you choose, Cloud Dataproc has some pretty big differentiation among the, compared to other cloud providers and the competition here. So with our features like auto-scaling and workflow templates, we make it really easy to manage both ephemeral and long-running clusters. We have both a high availability mode as well as strong consistency on our storage backend, which is Google Cloud Storage. And we even received external validation from an analyst firm, ESG, that Cloud Dataproc's TCO is less than half of on-prem clusters, and even 32% less than some of our cloud competition like Amazon EMR. So just to give you a feel for some of these features, I'm going to quickly jump into a demo that's going to show off some of Dataproc's features. Actually, you can go back to, there was a video on the last slide, in the slide deck. We'll just leave it like that for now. But essentially what this demo is going to show is my motivation for this demo is that as a product manager for Google Cloud, I find I spend a lot of time writing blogs and articles that I go out and put on the web. And what I'd love to have is a machine learning model that told me, is this going to be a good article or not? Are people going to like this? And so whenever I have questions like that, the first place I always tend to go is our BigQuery public datasets program, which has over 185 different public data sets that I can take and use to augment my analysis. And so the public datasets program actually had a perfect data set for my use case here. It has a Hacker News data set of every article written in Hacker News associated with a score of how well that article did on the internet. That score is a combination of upvotes as well as relinks, and there's a couple other things that go into that algorithm, but essentially it's a label that I could use for my machine learning application associated with the full text of an article. And so what I'm doing here is I'm just going to make sure I have scores greater than 0, as well as a length of text greater than 0. And that way I'm just cleaning up the data to make it a nice data set that I can process. And I'm going to take just the first 1,000 so I can better understand how to work with this data. And you can see what comes back here is a set of data that I can use to do this machine learning. Now, BigQuery is awesome for SQL, but I'd really love to take this out into Cloud Dataproc so I could do some things in R and with Spark machine learning and some other things. So what I'm going to do here is I'm just going to save this 1,000 row sample as a Hacker News sample data set, and then I'm going to jump back into Cloud Dataproc. Now, in Cloud Data, as soon as this job completes, I'm going to jump into Cloud Dataproc. Now, within Cloud Dataproc, what we do is through our component gateway, we expose the web UIs for components that are running on your cluster. So because of my Cloud IAM permissions, I can jump right into a Zeppelin notebook, which is a notebook for working with Spark. And the first thing I'm going to do here is just show you that that query I just ran in BigQuery, I could have run that directly in Zeppelin. There is an interpreter for it. But what I really want to do here is I'm going to pull that data into a Spark data frame. So I have this Python function that accepts an arbitrary table name, and I'm going to pass it my Hacker News sample. And just like that, I've now converted that BigQuery table into a Spark data frame that I can work with. And so I just want to do a quick check on the counts and double check that, yes, I do have 1,000 rows coming back. I'm good to go. And the first thing I want to do now is I'm going to, with one line of code, I'm going to take that data frame, register it as a temp table. What that lets me do is work across all of the languages of Spark, whether it be Scala, SQL, Python, R. I can now just move interchangeably between languages against that same data set just by registering that table. And you can see now I've flipped into R. And so I was in Python, now I'm using R against that same data set. And all the familiar things I would do in R with things like a quick filtering and aggregations and transformations, I can now do those on cloud scale data sets without having to learn something new. I can now, and there's two ways I can start to scale my analysis across Spark. So first of all, I could do something like a list apply in R, where I could take several models all at once with maybe different hyperparameters and send those all across Spark to all be trained, come back, and then I could pick the model that had the best hyperparameter tuning. But what I'm actually going to show here is another technique with a dapply, where I'm just going to run an NLP algorithm across that full data set. And that full data set here is only 1,000 rows, but it does give me enough of an indicator that, like, yeah, I'm on the right track with this model. I want to see how it looks if I'm trained against a full data set. So the idea here is I could send it a note of my, some text of my own and have a score for how that's going to do on the internet. So all I want to do now to train the entire model is I'm going to change my table name in the same exact notebook from sample to full. And then I'll just go ahead and I'm going to rerun that entire notebook, all that code steps you just saw, I'll just rerun that, but now on the full Hacker News data set. So as that's running, what I want to do is I'm going to flip back over to Cloud Dataproc console just so I can show you what's happening underneath the hood. So you can see I started with that whole time I was in a 3-node or a 3 VM cluster, which was totally fine for working with my 1,000 samples. But in about 2 minutes, what happened is my yarn pending memory spiked. So, and that's because I'm pulling in that BigQuery data. And so now the Dataproc autoscaler went ahead and added 2 nodes to my cluster to help me out there. But then what happens is you can see there's another spike in yarn pending memory. And so the Dataproc autoscaler has now spun up a full-size cluster to help me process that. Once the model training completes, I can simply hit refresh here just to show that the autoscaler is now going to take away those nodes because I don't need them anymore because the model training completed. And you can see where there is a spike, the memory wasn't needed anymore, and that's why the autoscaler took down those nodes for me. And finally, if I wanted to save all of this off without having to have a running cluster, but be able to retrain my model at any time, or I could hand it my next article and have it run against that article, that algorithm again, I could simply use a workflow template. And what that looks like here in the console when I go to workflow templates is I can simply click run after I've set that up, and that will spin up a right-size cluster for me that will run those jobs and then take down that cluster. And so Cloud Dataproc, we are really trying to change open source software to be cloud native. And so this means taking features that are fast, easy, cost-effective, and building around those. And so we launched more than 30 features last year alone. So this is still an area Google is heavily investing in. If you want to know more about specific features, we're going to do an entire Dataproc features session tomorrow at 11. We'd love to see you there. But for now, I'm going to hand over to Ravi, who's going to talk about how Qubit's actually using some of these features now.
Thanks, Chris. That was a great demo. Auto-scaling in action, really good. Hi, everyone. I'm Ravi Preti. I'm the platform engineer lead at Qubit. At Qubit, our vision is to have a world where every customer can have a personal experience with the brands they love. We want to create the greatest customer experience in milliseconds. We want to our mission is to drive customer loyalty and lifetime value through personalization. We work with enterprise customers across 3 main verticals: gaming, e-gaming, travel, and retail. In order to power these personalizations, we collect and process a lot of behavioral data. Let's have a look at some numbers. So at Qubit, we process more than 120,000 events per second at peak times. We have petabytes of data stored across thousands of BigQuery tables and other Google Cloud Storage solutions. We power more than 55 billion personalizations per month. That is around 8 per person on the planet. Google Cloud enables us to operate at that scale with ease. Let's consider a use case, a personalization use case, where a visitor is looking at a product page and you want to show some recommendations along with that product. So how do we go about it? It all starts from a user browsing through the site, looking at different categories, at different products, and as the user journeys through the site, we trigger a lot of behavioral data. We collect and process it. The architecture here shows how our pipeline would look like that solves this use case. We will revisit this architecture, but this time step by step. We'll follow an event from the start to the end as it travels through Qubit systems and see how we use the technologies which are relevant to this session, where Dataflow and Dataproc fit into the picture. The event that we are interested here is going to be a product event, somebody looking at a product page. The very first thing happens is a user is looking at a browser, it triggers an event or a mobile app, triggers the event, it enters Qubit via our Qubit gateway, where it's tagged with some meta information and moves forward to our very first data flow, that is the validation data flow. We internally call it the gatekeeper. As I'm talking about the first data flow in the architecture, let me share our experience with data flow, how we manage deployments and how we monitor them. Our experience with prototyping ideas with data flow has been really good. Since most of our code was in Java for the old pipeline, it was really easy for us to actually try those things out in Dataflow. Now looking at the Beam vision, obviously there is support for more languages, so I'm sure it will be easier for many of you here. It was in fact, we were actually able to move really fast, iterate and validate ideas really quickly. In fact, it was so easy to code and run these data flows that it almost gets you into this thinking called data flow thinking, where you almost want to solve all the problems using a data flow. It is that easy. In terms of deployment, we have our own in-house a data flow launcher that we use to deploy these data flow. It lets you seamlessly deploy data flows. You don't have to worry about paths. You don't have to worry about options, the plumbing code around creating PubSub subscriptions and things like that. By the way, we have open sourced it, so if you look on GitHub, you should be able to find it. As you can see here, we also have schema registry. So obviously, in this journey, we are following the product event. But in reality, we have thousands of different events, which have their own structure, own customizations per client, and things like that. In order to manage that, we have our own web service, which is Schema Registry, that helps us manage those schemas. I'll quickly talk about monitoring as well. So we use a mix of Stackdriver and in-house Prometheus monitoring. We started with Stackdriver, and it works really well. It has worked really well for us. We use it for monitoring things like undelivered messages in PubSub, or what is the system lag, and things like that. But we have certain unique requirements where we are interested in not just the freshness of all the events, but actually this product event for a particular client. That's why we host our own monitoring as well. So yeah, moving on, validation data flow. It looks up the schema from the schema registry, validates it. If it's all good and legit, moves it forward to our next data flow, which is the enrichment data flow. So suppose this event, we want to know whether it was actually triggered by a browser with human interaction or whether it was a bot doing that. So things like bot detection is what we do in the enrichment data flow. We also do things like currency conversion, time zone conversion, geolocation, and things like that. Basically, it adds a bit of a golden touch to the event. We internally call it no points for guessing, but Midas. After enrichment, this event is pushed forward to our next data flow. This is the persistence data flow. The persistence data flow makes sure that this particular product event enters the right table in the right data set. As you can see, we have schema registry doing a cameo appearance again here, but this time it's responsible to give us BigQuery specific schema that we can use to translate our product event into a table row type and look up things like meta information, like what are the partitioning columns for BigQuery and things like that. This completes our events journey, starting from the browser, traveling through our various data flows, and enters into BigQuery, our data warehousing solution. A bit of a detour here. So we at Qubit extensively use data flow in batch mode as well. One of the use cases, so just very similar to the one that we are talking about, suppose a client has an in-house generated recommendations. And what they want to do is use the Qubits one and their own, merge them together, and create more powerful personalization experiences. So here in this, as you can see, an automated system creates recommendation, pushes it into Qubit to GCS. We have services looking for these object change notifications via PubSub. We spawn on-demand data flow that reads the file, can auto-scale if the file is big, and finally pushes data through to Bigtable and to BigQuery as well. A quick note on unified programming model. We really love the unified programming model. Running the same code base in streaming mode and in batch mode is really good. You can think of use cases like suppose you have to do migration, and you want to have the same code base. So currently, if it's reading for PubSub, but you want to migrate data from, let's say, you have Kafka queue running to your new pipeline, all you have to do is just switch the sources around. So yeah, as of now, we have covered the first part of the architecture, which is our real-time streaming pipeline, where events has, it's all happy and good in the BigQuery. Now we'll move on and do something useful from that event. So this brings in Dataproc into the picture. So our recommendation workflow, this is how it looks like. Basically, that product event, we look at some of the interesting things from that event. What are, let's say, some attributes like, was it a blue color shirt? Which category did that product belong to, and things like that. Things that are required for our recommendation algorithms. We do that feature extraction, we prepare the input for our recommendation algorithms, and put it on GCS. Next up, we spawn on-demand Dataproc clusters, submit these Spark jobs, and produce the recommendations, which are now ready to be consumed by our rec service. So now, as we can see, we have sort of completed our journey where a product from the browser entered BigQuery, we generated some recommendations out of it, it is back on that page. So we've completed the whole cycle. As I was talking about, creating these on-demand cluster, as we have more and more clients coming in, more and more recommendation algorithms given by the data science team, we were spawning lots and lots of on-demand Dataproc clusters. In fact, we had thousands of Dataproc clusters running in a day, spawning and running in a day. We have also, one thing, if you follow that approach of actually creating on-demand clusters, two things that I'll mention is, first of all, as I said, the scale that we have used in, so in case you had that doubt in your mind, what if we have to create thousands of these clusters, we have used it in production for a long time now, so it should work for you. The second important thing is, if you do go with that approach, do have a look at scheduled cluster deletion, because sometimes if for some reason your jobs are stuck and you have these clusters being spawned, you probably don't want to make your bill go high and waste resources. Currently, we are also experimenting with using long-lived clusters with auto-scaling turned on, so we can use the on-demand clusters and a single cluster in tandem. In conclusion, fast prototyping. It's really easy to prototype and validate your ideas in both of these systems. So if you're thinking about it, I would recommend just go for it and see it for yourself. Serverless makes our life really easy. Auto-scaling, gives you that peace of mind, whether it's peak time or off-peak time, it's gonna, manage the resources efficiently. New features. Google has been great in launching new features. And as they launch new features, we retire our code, and we love that. Who doesn't really love, just removing old code that you don't need to use anymore? Last, there are a lot of online resources that you can look up. There's a wealth of resource out there. For example, writing data flow pipelines with scalability in mind by Ruben. There are a lot of blog posts actually written by Sergey as well, so you should have a look. In total, all these things have made our life easy. We can focus on creating new things rather than maintaining systems and worrying about days like Black Friday or Boxing Day. And we at Qubit can now focus more on our vision where every customer has a personal experience with the brands they love. On that note, I'm going to hand it over to Sergey.
Thanks, Ravi. All right, let's wrap up. Have a couple of announcements at the end. We also have time for questions. We have 5 minutes for questions. Please start lining up at the microphones. We would be happy to answer them. Nope, not yet. So Dataflow. Hopefully I was able to show how Dataflow continues investing into streaming, makes it really easy to work with batch processing, is open and scales resources and optimizes your time processing. Dataproc is an easy, fast, cost-effective way to run open source software in the GCP cloud. If you would like to learn more about Dataflow and Dataproc, come to these sessions on Wednesday and Thursday. We'd be happy to share more. I also have an announcement to make. A small one. If you would like to learn more about streaming systems, you can buy a book and get it signed by the members of the Dataflow team who wrote the book on streaming systems. They'll be here on Thursday at 1 p.m. It's a great book. I read it. I love it. And with this, let's get on stage and answer a couple of questions. And we'll start with perhaps this side.
Hi. So in the roadmap, would there be a Python runner which can connect to Spanner using Dataflow?
So the question is, will there be a Spanner connector for Python, for the Python SDK? Yeah. We are working on better supporting more sources. Spanner is one of them, especially for Python. We would like our Python connector support to be as complete as Java. And actually, if you look at There are a couple of short-term steps we're making, like implementing native connectors. But the bigger vision for Beam is to be able to use Java connectors and other connectors everywhere and mix up your languages together. So kind of the long-term vision is to be able to use all kinds of connectors already developed in a language that you prefer.
Okay, thank you.
Let's maybe take a question over there.
Yeah, hi. Great presentation, first of all. So I have two questions. So first one is, you mentioned EMR in your talk, right? So in EMR, before you spawn, you have options like, oh, I want Hive on this, Zeppelin on this, Livy, et cetera, et cetera. So does Dataproc also offer such options that I want these open source on the cluster?
Yeah, we do, and we have a couple different options for that. So first of all, we do have what's called an initialization action, which is custom scripts that you can write on your cluster. And when we talk to a lot of customers, and when we find that they're repeating the same things over again, like Livy's a good example of something that we just recently made an initialization action. But what we do is we identify those, and then we make starter scripts and put those into GitHub so you can just go. Now, what we also do is we monitor the use of those, and when we find that there's just a very repeated, again and again, everybody's using like something like Presto. What we do then is we turn it into what's called an optional component. An optional component is something you can just take with a checkbox, and it'll actually become part of the cluster, and it's actually part of the image itself. So when it's actually part of the image, that does two things for you. One is that it will make it so you get that fast 90-second spin-up time, but also it makes sure that everything is actually integrated with each other because it's on the same image. So that whole menagerie of open source software that's running, it's actually working in tandem and not stepping on each other.
Yeah, so that's interesting because I was thinking that how would auto-scaling work if that optional component is enabled? Because let's say you have HDFS or Presto and you have auto-scaling enabled. So in AWS, you have your core node, task node concept. You cannot auto-scale core nodes. So how does that work in Dataproc exactly?
So our autoscaler is based on Yarn pending memory. And so Presto actually does not use Yarn. So that's something that we're thinking about doing, and we'd love to hear feedback if people do want a Yarn autoscaler. That would be something that we could look into. But for the most part, like a lot of the different languages, you know, Spark as well as MapReduce and et cetera, they're all using Yarn as the scheduler, and so we just monitor the pending memory there.
Okay, and one question for Ravi, I guess, would be, you use both Dataflow and Dataproc. So what was that tipping point where you decided, okay, this is where I stop Dataflow, and now I need to do things in Dataproc, and vice versa? So what do you think in your experience is that point?
Well, so yeah, our data science team was actually, working with these Spark jobs along with our platform engineers. And so at that point, we thought, okay, we should use Dataproc. It will be easier for us to just go for that. That was the main reason. And also, it fits nicely with Dataproc because if you have been running it locally in that kind of, then it just works well rather than actually trying to run that as a data flow. That has worked well for us.
Okay.
Let's go to the right. Go ahead.
Great presentation again, thank you. So my question is about the Qubit as well. Wondering where the source data is for the web behavior data. Is it from Google GA or is it from your CMS system directly?
Sorry.
Comment on that.
Could you, where do we get the data, collect the data?
Yeah, get the data, the behavioral data, which gives you that send the event at the point of the, it happens. Because for some of the applications that I know, the information is sent after the session is closed. So
Okay.
I'd like to understand, where that data is coming from.
So for us, I mean, if it's browser, then we obviously have some sort of JavaScript snippet running over there that clients actually implement their code and they push data through. We collect there on this client side. For mobile devices, we have our own SDKs that can your app developers can actually connect to and push events through. So it happens on sort of every page view. We trigger a lot of data, and then that's all bashed together and sent via these code snippets.
So you're not using anything like MoveForward or Sitecore or GA to, you don't rely on that kind of information for signals?
Are you using Google Analytics?
No, so we don't actually. We do have some translation logic so that you can actually read up from GA and actually convert them to qubit and send it over. But we don't directly hook up with GA. What we can actually do is, if with the cross permission, because I think GA can actually have data now in BigQuery, so you can have some sort of cross permission around Google projects, and you can actually access that and join them together to do more powerful things if you want to.
Let's do one more question on the left, and we are out of time, but we would be happy to answer your questions after the close of the stage. We'll be right there. So maybe gentleman from the left.
Thank you. My name is Ram. I run the product management for big data platforms at Salesforce. So I take it that you're putting forward, Google is putting forward Dataflow as the real-time streaming analytics solution, stream processing solution, in competition with Apache Spark Streaming. So what are the key differentiators there? And then the second part of the question is, you showed that the PubSub is the source for the events to go into the Dataflow, right? But Dataflow, does it also connect to other technologies like Kafka and other, or even static data like databases or blob store to convert into streams?
Yeah, so let me see if I got the questions right. So what are the differentiators between Dataflow and Spark? And what are the other options for connecting to data sources?
Yeah.
Sounds good.
Spark streaming, yeah.
For streaming. First off, our customers still tell me, my users still tell me that the streaming APIs that Dataflow provides us are easier to use for streaming than the Spark API, even the Spark, structured Spark APIs that we developed recently. We have a unified batch and streaming API, and it's easier to use than the Spark one. In terms of data sources, we have a Kafka connector, we have a PubSub connector, and I'm actually seeing quite a bit new customers coming from the Kafka world. They are happy with Dataflow because it solves their needs. Dataflow overall, Dataflow has the advantage of relying on Beam. Beam has 30 plus different connectors. All of the data stores in GCP are covered. A bunch of non-GCP products as well, Kafka, S3, HDFS, Avro, Parquet, lots of different things are covered, both on the static file side as well on the streaming side. We have a GMS connector and MQTT connectors. So there's quite a bit of a connector ecosystem that is part of Beam.
Okay.
And we reuse it. We automatically get advantage or can rely on it in Dataflow.
Wonderful, thank you.
Right, we'll be happy to thank you all for coming at this late hour. We'll be happy to take your other questions after this session.